Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, what's up, everybody?
That's dope.
Last office hours of 2025. I seriously need a break, though. Yeah. We have been on a tear recently with streaming and tutoring and teaching and all that fun stuff. It's been great, but this is the last one until next year.
Good job.
We will have one more stream, though. Santa Gold is coming to town. I think it's on Monday. Are we doing it on Monday? I think we're doing it on Monday. One sec. Let me get the stream starting on here. Why is this not casting correctly? There we go. The hell? There we go. Okay. Nice. And we just hit 2,200. Sick. Oh, yeah. It's been a good close of the year. I apologize. I wasn't able to stream yesterday. Because I had to be on a boat. It was it's for my new job. I got some pictures made for you guys. I'll show you. Let's see. What? Come on. What the hell? Got caps lock on or something? One sec. Oh, man. There we go. No? There we go. What's up, Millie? You done with your classes, Millie? You still got finals? What's going on? How does your I think you have like an abstract algebra class or something that you're doing. Also, let me make sure my stream settings are set up okay. Someone was saying that like they couldn't stream unless they were a subscriber. So I think I changed that. Whatever, I'll fix it later. All right, yes, welcome everyone to the last office hour stream of 2025. I assume you should be done with school No more exams, especially not coming up to next week. It's Christmas next week. I myself have been, pretty busy with things, but I think we're done. There we go. That should be working. Yeah, okay, that's working. Let's see. News in the server. We do actually have some news. We're doing a giveaway on. Let me see. What day? What did I say I was going to do it on? Okay, there we go. Sorry. According to the Discord, in the announcements, Santa Gold giveaway stream Monday. Cool. Yes, one final stream for 2025. That's gonna be Monday at 1 p.m. Pacific, 3 p.m. Central, 4 p.m. Eastern. So, if you want to enter the giveaway and you want to get triple entries, so one way to enter the giveaway is just to show up to the stream on Monday. If you do that, that'll get you an entry. But if you want triple entries into the stream, the best way to do that is to fill out this form. So there's a cute little form here. It's kind of just like an end of the year survey thing. We're just trying to collect some data on like what you guys liked about the streams, what you liked about the Discord, blah blah blah, and how we can do better next year, and whatever. Feedback is great. Also, the more people that enter with the more people that enter with the form, the more prizes we're going to give out. So I think for every 5 people, we're going to do another $10 drawing. So I don't know, someone can work out the expectation value there, but you always have a 1 in 5 chance. And I think, let me see, how many people have submitted so far? I'm actually curious. Let me check. What's up, Taco? We're up to 25. Okay, cool. So there will be a grand $50 prize, and then there will be 5 $10 ones so far. $100. But if you want to enter, it's still open. It's right there in Discord. So just go check it out. I'll make another little reminder announcement on Sunday or something before we start. How is Zach's stream doing, by the way? Zach was doing, I think he was trying to do 1,000 minutes or 1,100 minutes. Let me see what he's at, actually. He probably has it on his Twitch. Or actually, even better yet, it's probably on the calendar, right? Yeah. Not this one. Where is it? Actualofficehours.com. There we go. If you go check out the streaming schedule. Let's see what we got. Yeah, we have our stream. Oh, Zach had his, oh, nice. I hope their podcast went well this morning. I was at the gym this morning. I didn't even check anything. What's up, Machka? But yeah, it looks like no more streams. We do have Santa Gold happening on Monday. Nice. Well, I do need to probably redeem Bondcoin stuff. And then it looks like Zach is going to start again with streaming starting January 3rd. Brave man. Okay, cool. So yeah, go fill out the end of the year survey. We're going to have a fun giveaway on Monday. And hopefully you guys are enjoying the holiday break. I will definitely be enjoying the holiday break. And then I think I'm going to do a thing similar to what Zach did. I really like Zach's end of the year little document about planning out the server and stuff. And I think we're going to use the results of the survey to kind of come up with an idea for what we plan to do next year. I think we have a lot of things that work so far, and I'm going to keep doing those. Like the office hour streams definitely work. They definitely help out a lot of you guys. There are ways we can make it better. But I want to in the future add more community events. So more gaming stuff, more podcasts, more, not just help me with my homework. But help me with my homework is great. I mean, it works. The numbers don't lie in terms of stats, but more fun stuff planned ahead. Okay, cool. Let me see. I think we already have 1K's already got a submission in to the Discord. So let's start off, help you guys out with some questions. And here we go. All right. Welcome everyone to Office Hours. My name is Dr. Gold, Psych Education. Extremely helps you out with math homework and science homework. Let's start off on TikTok. and YouTube. All the chats. Ooh. There we go. All right. Let's see. What's the first question from 1K? What do you got for me, 1K? And Gladiator Leo's already up. Oh my god, what's going on here? Dude, Jesus, excuse me. What is this? What's going on here? Solubility rules, it looks like. Chemistry. Where's my chemistry gang, dude? Okay. Then let me get all the chat clients working. Nope, that's not them. Morning, Alistair. Are we gonna call you the JBL god? Is it also a rule that you have to play Trap Queen on a JBL? Yeah, recognize it. Dude, I love how it's all rainbow color coded too. It's kind of fun. I don't really remember much about solubility, but okay. Actually, no, I kind of do remember this. Interesting how solubility goes down for some things as temperature goes up. Is it the unwritten rule? The CEO of JBL. I like JBL speakers. They're solid. I have a pair of them I use all the time for whenever I'm doing like little like mobile DJ gigs that I need like stuff that's just battery powered. I'll show you my setup. Where's my JBL speakers? Yeah, these are them. It's a thing on TikTok, really? Okay, well these are my JBLs. I got a pair of Party Box 100s. It's fun. You can run them in stereo actually. They're pretty people with specifically JBLs. I get it. I know. It's kind of like probably some hood thing. People and they're just playing Fetty Wap 1738. No. Is that the song? Did I get it right? Did I sing it right, guys?
Oh shit, not good.
Fucking funny. Okay. And they walk into fast food places, yeah. I can definitely help you. Eli, if you want to help with the chem problem, for those of you that are just joining in, the way to do that is go to this website, actualofficehours.com. Type in a username you want me to call you, and then drop in a screenshot of your question. This is a chemistry question that actually came from 1K, which is asking about solubility curves. And so let's just define real quick like what solubility is. So like solubility is like the ability to dissolve solutes into solvents. How I usually like to think about this is like whatever the powder is, and then this is basically the liquid. The solvent's usually water, and then that creates a solution. Right? A solution is when you have like some solid that's been dissolved into a liquid. Oh, nice, Eli. I see your question. You're good, dude. And that solubility changes with temperature. So in general, when you increase the temperature of things, solubility goes up, which means that you can put more of a solid into a liquid. There of course always reaches a period where you can't put any more solid into a liquid, and that's called like a supersaturated or oversaturated state. You can think about this, I don't know, have you guys ever tried like take salt and like dissolve it into water, right? You gotta like mix it and stuff, yeah? There's only so much salt you can put in the water. Eventually, the salt will just pool at the bottom if you're trying to like dump a ton of salt into liquid. And that's an example of like reaching the solubility limit of something. So this is showing a bunch of different, I want to say solvents. Actually, no, sorry. These are a bunch of different solutes, actually. Okay, cool. Sorry, actually. So this is the grams of salt. Okay, and now this is the key thing. So y'all in the, everyday life think about salt as like table salt. And that's sodium chloride, NaCl, which is on this diagram right here. This is NaCl. That is a salt. That is the salt we think about. But these other things are also salts. So, for instance, calcium chloride is a salt. Potassium chloride is a salt. I guess lead nitrate is a salt. I forget what like actually qualifies something as being assault. Usually, an assault. You ever seen that like assault with a deadly weapon? That's another pun that comes up all the time. Anyone see this? Yeah, assault with a deadly weapon. It's like, yeah, I don't know. So I think assault is usually an ionic compound where the cation, which is the thing in front, is usually either like potassium or magnesium. It's one of those like group 1, group 2 elements. And then the anion, the thing on the end, I guess can be whatever. It's usually chloride. Nice. You didn't know, says I passed calc with a C. Congrats, dude. C's get degrees, so I'm glad you passed at least, but maybe let's do better next time. Yeah, that'd be kind of dope, right? Okay, so what this is showing is solubility grams of salt in 100 grams of H2O. So this is saying, for instance here, this blue curve for NaCl is saying that at, let's look at, I want something like here, for instance. At 80 degrees centigrade, this water is able to dissolve 40 grams of NaCl in 100 grams of water. And that changes as temperature goes up. So, for instance, as I would assume as the H2O is getting hotter, the ability to dissolve these things goes up. Except apparently for, like, cesium sulfate. That's weird. No. What's up, 23 Pro? What's the point of these? Point of what? The streams or the solubility tables? The point of the streams is to help you with chemistry. The point of the solubility tables is to show you how solubility depends on temperature. That's how that works. Okay, okay, so it says how many grams of calcium chloride can dissolve in 200 grams of water at 10 degrees Celsius. Okay, that's cool. So we need to look at calcium chloride, which is right here. We need to look at 10 degrees Celsius. So 10 degrees Celsius is here, right? And so that tells me, I don't know, what is that? It's between 60 and 70. Nice, good job, 23. Yes, post your grades. You'll get credit for it. So I don't know, what is that? That's like 63. 63 grams. And that's per 100 grams of H2O, right? And H2O is water. So if you have 200 grams, then you can do twice that, right? This is 63 grams per 100 grams. So per 200 grams, that's going to be 126. Okay. So then it says, if 25 grams of water saturated with KClO3 at 70 degrees Celsius is cooled to 30 degrees, how much of this salt will precipitate out? Cool. So precipitate, that's the solid bits of the powder that you see that's not in the liquid anymore. That's what a precipitate is. And so, okay. 25 grams of water saturated with KClO3 at 70. So where's KClO3? That's here. Okay. So at 70, you got a solubility of around, what is that, 30? Okay, cool. And then it's cooled down to 30 degrees, which now has a solubility of 10, right? Okay. So that goes from 30 grams of solubility to 10 grams of solubility. So saturated means we're at the limit, right? So I'm going to assume that yeah, because they don't tell us how much water. They just say that the water is saturated. So that means that you don't have 100 grams. Because if you had 100 grams, you could actually put an additional 5 grams of KClO3 into it. So basically, this decreases by a factor of 3. So 25 grams being saturated means that now only 25 divided by 3 can be saturated. So we can say here that like 25 grams divided by 3, right? So this is like a factor of 3. Or factor of 1/3, I guess. And that's going to be, 8.16 maybe? No. 8.3. No. Yes. 8.3. 8.33. What's up? Time complexity? What's time complexity? I don't know what that is. Okay, so 8.33 grams can be dissolved. So 25 minus 8.33, which is going to be 16.67.
You done messed up, Aaron!
Grams will precipitate out. Okay. I know. No. It happened. Okay, determine if a solution is unsaturated, saturated, or supersaturated. Okay. Actually, I'm curious. What is the difference between supersaturated and saturated? I assume saturated is like at the limit and supersaturated is above. Okay, yeah, so it's just maximum. Yeah. Okay. Mm-hmm. Okay, cool. So I guess, I mean, saturated is kind of a unique thing. Okay, so 45 grams of KNO3 and 50 grams of water. So if you look, and at 50 degrees, so there's a bunch of different things you gotta look for here. Yeah, so saturated is the condition that you're exactly at the limit, I think, Usagi, right? So KNO3 at 50 degrees centigrade can hold about 90, right? But that's for 100 grams. So at 50 grams of water, you half that, so 45. So this is going to be exactly saturated. Okay, NaCl, 25 degrees. That's there. So that's like 35, but that's at 100 grams of water. We only have 50, so it's like 17. So this is unsaturated. And then 80 grams of potassium dichromate. Where's that? There we go. At 90 degrees, it can hold 70. We're putting 80. That's more. So this is super saturated. My cola gets super saturated at first when I pour it. Really? What, you see like the solid come out? What's up, 1K? Yeah, okay. Name and describe the factors that affect the solubility of a substance. I want to say like IMFs are highly dependent. I think intermolecular forces do. Temperature, obviously. And then, what else? What else do we think affects? This is chem. Yeah. Solute-solvent interactions, which is polarity, which is kind of IMF. Okay, polarity, surface area for sure. Yeah, if things have very high surface areas, they can dissolve easier. So yeah, surface area. You had a chemistry unit test and a math unit test. Wow. That's a lot, dude. Yeah, surface area, pressure, and then I don't know, we can also say like polarity. Explain how you can determine if a solution is saturated, unsaturated, or supersaturated. I think just visually. Can you just visually look at it? So if you can dissolve more, it's unsaturated. And then, right, if you can't, then it must be saturated. And if you already see stuff there, then it's supersaturated. Cool. All right, cool. Good question there, 1K. All right, let's add that to the Discord. So yeah, if you're watching us right now on any of the channels, and you want to submit your own homework question for us to go over, the website to do that is actualofficehours.com. You can drop in your screen name, put it in the screenshot, we'll do it. And then after we do your question, make sure you can click this link here to join our Discord. Because... Oh, no, I don't need this. Because we'll also drop it here. And not into this one. This is our giveaway stream we're doing on Monday. But here, homework help. So this was 1K's question that got asked. And then I'm just going to drop it in. Where's the screenshot? Listening to Gold stream while biking is poggers. Nice.
Oh, yeah.
I mean, please focus on the road. Don't, like, get hit or anything. All right, cool. Let's see what the next question is. Jesus loves you. Truly have faith in him to be saved. Thank you, dude. I always need more, like, people praying for me, or Jesus Christ, or whatever in my life. I actually found out about a really cool religion. Actually, I was helping a professor out today, with getting their course set up at, I think, the Ohio State University, and they told me about, I don't know, this just came up in discussion about the Baha'i faith, the Baha'i religion. Do you guys know about this one? I don't know, it's apparently pretty cool. It believes in the oneness of God and basically the oneness of religion. And I honestly, I'm technically Catholic, and I'm not super spiritual or whatever, but I do also very much believe that all religions are basically pointing at the same shit. You know, it's like everyone's like pointing at the sun and they're like calling it different things, but it's all the same. So, very cool. I learned about this actually today. It began in Iran actually, which is really cool. I've been watching a lot of Iranian related shows too. There's a TV show called Tehran on Apple TV that came out that I was like, oh, pretty interesting. A lot of my friends are Persian too, so Befameh, that's what we say. Let's move on. Yes, in Iraq, yeah, dude, Persian food is fucking fire, dude. Yeah, like I love, what is it, Gormazabzi, Kubide, Taishin. Taishin's great. I do watch it dubbed. I don't speak Farsi. I dated a Persian girl actually for like a couple weeks, and I learned a little bit of Farsi. I like learning languages. They're fun, and also like you have a reason to learn a language if you have someone that you're trying to speak to. Otherwise, I don't know. Like that Duolingo stuff is like pretty mid. Like you're never gonna remember it because you don't need to actually use it. It's the same thing with math and chemistry and physics and all this stuff. You have to have a reason to do it for it to stick. So, all right, what do we got? The star Gliese 667cc has a mass of that, and if the semi-major axis of the planet is that, calculate the orbital period. Wow, that's cool. Is there an equation for this? I want to say it's t to the third equals a cubed. Or equals, was it t to the fourth is a to the third? 6.47. No. Yeah. Do they not speak Pashto? No, I think they speak Farsi. Yeah. The only reason I'm learning math is for my entertainment. Great. Okay, there must be an equation for this. I know about this. I'm pretty sure this is like Kepler's laws, right? I think this is Kepler's laws. Kepler's laws for orbits. Oh, sorry, it's t squared goes as a to the third. Oh, this is fun. Who drew this cool little fun little thing? Okay. Pashto is a language that is a tribe that the Pashtuns speak. Oh, I didn't know that. There's a lot of different languages. Honestly, even like Italian, like my heritage is Italian, but even like formal Italian didn't really come to be until like the early 1900s. Like everyone used to just like speak dialects, like slightly similar but technically different. And then eventually there's a government and they're like, okay, but this is the language we need to speak. Antonio Margaretti. Margaretti. That's a good one. Can you derive Kepler's first law? I don't think I can. Is this Kepler's first law? What is Kepler's first law actually? I'm curious. Oh, okay. every planet orbits the sun in an ellipse with the sun located at one of the two foci. Oh, that's cool. Yeah, this is more kind of like astrophysics stuff. I didn't really do much astrophysics. I know what a focus is in terms of like an ellipse. That's pretty cool. Oh, you can do it with conic sections. I think it has to do with this, right? That planets sweep out equal areas in equal times. Is it from the second law? Oh, that's something we can look at if we got some time. I'll go into it. For now, though, if you have to solve this question, it helps to know Kepler's third law, which I did know this. I knew it was something a to the third. Okay, so t squared, this little funny goldfish thing here, this is called like alpha, which means is proportional to a to the third. So it doesn't give a number, it just gives like a ratio. So for instance, if t goes up by a factor of, I don't know, well, it's actually kind of weird. If t doubles, right? So t would then a cubed has to go up by a factor of 4, but fuck, I don't know. Like what's the cube root of 4? What's a better way to do that? Let's say if t goes up by a factor of 4, then a needs to go up by a factor. No, that doesn't work either. I don't know. Someone come up with like some fun numbers. Something to the 3/2 power. Square root but cubed. Yeah. Oh, that's what it was, Pegasus. Yeah, okay. Oh, so it was fascism. Okay. Well, I guess fascism has like some benefits sometimes. It's usually not very good, but it did at least unite the country in terms of language and other bad things, but the language was great. All right, so this is the form I remember, and it's good for like proportionality and stuff. 4 to the power of 1/3. Yeah, I don't know what 4 to the power of 1/3 is though, right? I wanted something that was a nice number. You know what I'm saying? I guess if t went up by the square root of 8, then a would go up by 2. Is that what we could say? But like square root of 8 isn't a nice number either. I want something where like there are nice numbers for each one. I don't think it works though. Yes. If t cubes, if t is cubed, then a squares. If t cubes, 4 to the power of 1/3 is a mean number. Yeah, it's a pretty mean number, dude. Do you know what 4 to the 1/3 is? I don't know what it is. Okay, but to the point. This one is the more formal way, which this is like an approximate thing. So they say period squared. Okay. So we can say this. Period squared is about, we're going to say 4 pi squared big G, which you guys are going to love this number. You're going to love this big number G. I know you will. Because big G is equal to 6.67 times 10 to the minus 11. There you go. Big G. Big G. Big dog. Yeah, there you go. This is Big G. But is it the OG? Good question. Nice. Good to see you, Zach, by the way. Zach, did you finish your how many minutes do you have left on your streamathon? Zach's been doing an awesome thing as the year closes for celebrating 1,000 followers. Congrats, Zach. Where he's streaming at least 1,011 minutes, and then for every new subscriber or follower he gets, he adds another minute. 0 minutes. Oh, you did it. Oh, congrats, dude.
Good job.
Was it during you and Penn Center's podcast thing? Did I miss it during that? Or did you independently do it? I look on the calendar for things. I get so many notifications on Discord these days. And Twitch, honestly. It's nuts. But congrats, Zach. That's dope, dude.
That's dope.
What is that? 1,000 minutes is it's at least like 14 hours, no? Oh, it was during a philosophy stream with Don and Slim. Sick.
Oh, yeah. Good job.
That must have been fun. With me doing Legos. Nice. Which STEM undergrad exam do you think is the hardest worldwide? Anything JEE. That's always the hardest. Because I don't even want to do those. Hey, 6.67 times 10 to the minus 11. And then the mass of this planet is 6.47 times 10 to the 29th. And then a cubed, so that's going to be this massive thing, which I think needs to be in meters. They put it in kilometers. So you got to be careful about this. Physical chemistry is pretty hard. I would agree. Yeah. So 18715,000. And then kilometers to meters, you got to put another 3 zeros on it. This is something that's probably nicer just to put in scientific notation. So let's do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we're going to say this is 1.8715 times 10 to the 10. Just a little bit easier to look at. Yeah, I can definitely do further level math. Ducks in chemistry. We had chemistry earlier. And I think our next question from Eli. Eli asked a chemistry question we're going to do. I don't think he built... Yeah, I think he built Wall-E, I want to say was his Lego thing. I think he built Wall-E, right? Alright, let's pull up the calculator. Let's get some numbers. 4 pi... Is it 4 pi squared, by the way? It is 4 pi squared. Oh, that's kind of fun. What? Okay, 4... It is 667C. I actually didn't notice that. Then times 1.8715 e to the 10th divided by 6.67 e to the negative 11th. And then I'm going to do another divide by 6.47 e to the 29th. The 667 is killing people, dude.
Surprise, motherfucker.
I know. Well, that's actually a very, very low orbital period. I actually don't get that. Wait, what?
You done messed up,
Wait, what? Oh, we forgot to cube this thing. Sorry, this needs to be cubed. I was like, yo, what? This is like nanoseconds. You can't have nanoseconds for a period. This is your favorite problem of the day. I'm glad, dude. This is supposed to be to the 3rd. Oh, man. I gotta remember how to like do this on the calculator though. Let me put like a second insert here. Wait, why is this? Yeah, okay, there we go. And then we just do this to the 3rd. Okay. There we go. That's much better. And then we're going to divide that by 6.67 e to the negative 11. And then we're going to divide it by 6.47 e to the 29. Nice. There we go. So like 6 times 10 to the 12th seconds. Oh, but that's t squared. Okay. But then we need to square root it because it's t squared. So we're not done yet. And then Jeff, yeah, Jeff put a good thing there. 10 to the 7.5 is a year? Really? 10 to the 7.5? That's a peculiar number. 86. I thought 86,400 seconds are in a year. Am I wrong? No, wait, in a day. Sorry, 86,400 in a day. Yeah, that's right. Okay. So here, we can divide that by 86,400. Oh, so I think this is kind of what they want. They probably want this. 28.34 days. Yeah, I think this is what we want, right? Because we had to square root that 6 times 10 to the 12. Nice. Cool. All right. Good question there, Gladiator. Partial derivatives, Ben says. He says, do the partial derivatives. Well, if you want to submit a question on partial derivatives, I'll do it, Ben. We just finished Gladiator's question. Great job. Fun one. We've gone from chemistry to the cosmos. Where will we go next? Eli is going to take us on a ride somewhere else. Where are we going? We're going, Eli. What's our next question in the queue? Actually, I don't mind partial derivatives. I just can't do partial differential equations. Ooh, okay, here we go. Balancing equations. I got you, Eli, dude. This is fun. I love balancing equations. Yeah, this is sick. I like doing this stuff. Where's my foot pedal? Okay, there it is. Yeah. Okay, here we go. Indicate the coefficients needed to balance the following chemical equation. Yep, we love balancing. So whenever this happens, and this is actually really nice because there's only 2 real elements I got to deal with. You should always kind of like write out what the different. So we have N's and we have O's, and we're gonna put NO on the other side. No. Or PDEs are why computers are invented. I didn't know that. Just because like numerical analysis is a lot easier, probably. All right. I'm going to assume all the coefficients are 1, just to start, okay? Just assume they're all 1. And let's add up what we got. So for nitrogen, I have 2 nitrogens here. I have 1 here, so that means I have 3 to start with. I have 5 oxygens here and 1 oxygen here, so we have 6 to start with. And then let's look at the right, what we got. Ooh, I have 1 nitrogen and 2 oxygens. This is actually pretty nice just to balance already. So you always want to try to balance the most complicated thing. Here, that's not entirely obvious which thing is complicated. I'll give like a quick little here. Let me see. Little example of something a little bit more interesting. Yeah, here we go. This is a good one. Something like this. Just for, we'll do yours, Eli. It won't be too bad. But I want to show you if you had something harder, for instance. Let's say you had this. Let's say you were trying to balance this one, okay? In this case, the most complicated thing is this. And you want to try to balance the carbons first. Anything that's left by itself, so like on its own, like alone, like doesn't have anything attached to it, this you always balance last. Okay. So I2 you'd balance last here. O2 you'd balance last here. O2 you would also balance last here. Because that's some number that you can just like kind of mess with at the end. So yeah. In this case, this is like not too hard of a one to solve, so we don't really need any big special tricks. So, okay, I got 3 nitrogens here. How could I get 3 nitrogens here? Well, the way to do that would be to put a 3 on here, okay? Now let's count what we got. So now it's 3 times N, so this goes and becomes 3. And then how many oxygens do I have on the right? It's 3 times O2. This multiplies by this to get you 6. Okay? So now you're balanced. This was super nice. And you're done. Do you see that, Eli? That one's like not terribly difficult. I can do a slightly harder one for you if you want. Education stream on my Brainrot app. It's more likely than you think, dude. How to submit questions, actualofficehours.com is a website right there. Go to that website, drop me a screenshot. I'll help you out. I want to do a more fun one to balance. Where's a more fun one? Let's do this one, actually. I actually do want to do this one. Let me just do this one. I feel like this one would be cool. Yeah. Let's just get rid of this. Because this one was fairly simple. But let's learn some shit, right? We wouldn't be here if we weren't learning, right? Okay, this one, a little bit more fun. So we got carbons, we got hydrogens, we got oxygens. This is actually a special type of reaction. This is called a combustion reaction. The reason why it's called a combustion reaction is because you have a hydrocarbon. So hydrocarbon, carbon and hydrogen, being mixed with oxygen, and that produces CO2 and water. That's combustion. If you ever wondered like how you burn shit, add oxygen. You need like some sort of like catalyst or like starter. And then it'll produce CO2 and water. It's a redox, right? You're right. Combustion is also a redox reaction. Yes, yeah, this one was just 1, 1, and 3. Yeah, this one was very simple. You just had to slap a 3 on this one, JS. You should always assume 1. So here's what I'm gonna do for this one, right? I'm gonna assume 1 for everything. Just starting out, okay? So if we count the number of carbons on this side, this is 8. Hydrogen's gonna be 18, and you're gonna have 2 oxygens. And then on this one, you're gonna have 1 carbon. Hydrogens, you got 2. Burning octane, like gas. Yeah, I think this is octane. Yeah, octo, right? Yeah, C8, yeah. Oxygens, you have 2 from here, you have 1 from here, so you have 3. Okay, so nothing, like, works. So, I'm pretty sure it's octane, IKEA. It makes sense. I think it's octane. Miri says, I don't get why it's called that. You don't get why what's called what? Oh, why is it called combustion? Oh, it just refers to a process. It's a special type of reaction that involves burning things. And again, you can always recognize this because anytime you have something plus oxygen producing carbon dioxide and water, you're probably burning it. It is octane. Cool. Nice. It is gasoline. Okay, so oxygen I'm going to balance last. I'm going to try and balance carbon first because I think that's the most complicated. So I have 8 here. How do I get 8 carbons over here? I'm going to change this 1 to an 8. Well, no, yeah, exactly. Yep. So now this, you got to update everything. This is 8. Now we have 16. We have 17 oxygens. Okay. And then hydrogen didn't change. Okay, so this is balanced. But the hydrogen is not. Okay, so how do we balance the hydrogen? Well, I have 18 here. I have 2 here. So let's put a 9 in front of this. Teach them this. CXHY. X plus... oh, that's another Pogify. Oh, that's cool. I generally don't like teaching, like, specific rules for things. Because, dude, chemistry already has, like, way too many fucking rules. No. Like, there's too many exceptions and stuff. I like to teach the process. And then they can, like, figure it out. Yeah, sure. I got it. Yeah. But that's cool. Yeah, you need heat to start the reaction. It's like you have to get over, what is it, the activation energy or something. So, okay, let's count. So now we have 18 hydrogens. That's great. 9 times 2. But our oxygen situation is about to be a mess. Because I have 16, 8 times 2 from here. And then 9 times 1 from here. So I have 25. This is actually a really cool question. I really like this one. I need to balance oxygen. Remember, there's a reason why we balance this thing last. And that's because it's by itself. Because if I change numbers in front of this, I don't fuck up everything else. Like, I'm not going to mess up my carbons or hydrogens. I'm literally just changing oxygen. Which is nice. So, I need 25. This has 2. This is kind of weird, right? Because you should ask yourself, wait a minute, how am I going to put a number in front of here and get 25? Well, it turns out you can't do it with a whole number. You have to do it with a fraction. And what that fraction is going to be is 25 over 2. Because when you multiply this by this is going to cancel, and you're going to end up getting 25. So, the other way I kind of like to think about it is you say, okay, how many moles of this do I need? 25. And then you divide by whatever the subscript is here. So 25 over 2. Because now, 25 over 2 times 2 gets you 25. However, we are not done yet because chemistry says you can't have fractions here.
No.
So we got to get rid of the fraction. So the last thing you got to do is multiply the whole equation by whatever that denominator is. Exactly. You're right. Multiply by everything. We'll get rid of this 5. I don't care about this. So 2 multiplied by all this will then give you 2C8H18 plus 2 times 25 over 2 just gets you 25. Plus 16O2. Or, sorry, reacts to form 16CO2 plus 18H2O. Yeah, they just don't like the fractions. I don't know. Dude, chemistry has like so many rules and formalisms. Don't even get me started with like naming and stuff. Dude, I don't know. Like IUPAC needs to like die.
Disqualified.
But anyways, yes, there you go. That's the correct answer. And that's how you do it. Nice.
That's dope.
Is this another 24-hour live? No. No. I'm live for the next 2 hours, not the next 24. I still can't believe I did that. I can't believe I streamed and sat in a chair for 24 hours. It was very painful, actually. All right, nice, Eli. Hope that helps you out. Anyone else who's watching, yeah, I hope this kind of like illuminates some cool chemistry stuff. I love to teach chemistry, and I especially love to take like simple examples and then show like what's going to be the more complicated thing that your teacher's going to ask you next. Like looking ahead, it's like the cheat codes. Wow, you actually are a good teacher coming from a medical aspirant. Thanks, dude. Yeah. I've been in the game for a second, dude. I've been in the game for a hot minute. Pegasus says, try splitting O2 and keeping it stable as an ion. Isn't that ozone? Or is that O3? Is ozone O3? My pet theory is that IUPAC reformalizes compound names every 5 years just to justify their pet. Yeah, probably. It's like what they do with, what is it, the diabetes, the insulin patent, right? They change like one little fucking molecule on it every whatever so years so that they can't make a generic form of it because they want it to be something new because the patent law would like run out the trade. I don't know, it's just garbage. Anyways, let's see, what do we got next on the queue? Yes, I am doing the questions in order, so here we go. Next one's from Machka. This is beautiful. Real fun. This is going to be physics. Wow. We've gone from chemistry to the cosmos to physics. Insulin monopoly, yeah. It's only in the US too. I believe like overseas and like not in the United States, it's fine. But for whatever problem, the United States just hasn't figured out, or unfortunately pharmaceutical companies have figured out how to like basically like rob people. This is really math. Okay, we're going back to math. Okay, great. All right, a particle moves along the line with this. Determine all intervals of time in which the speed of the particle is decreasing. Ooh, very fun. So if this is position, speed, really velocity. We really should say velocity. Oh wow, they're saying the speed of the particle is decreasing. This is especially a pain in the ass.
No.
Yeah, okay. We're gonna get to it. Okay, so velocity, we need velocity, and then I'll talk about like how speed works. So velocity is equal to dx dt. Yeah, exactly. That's Jeff has it. Jeff has it down. Yeah, we're gonna have to look at the sign of the velocity and the sign. Yeah, dude. Ugh. Yeah, fine. Okay. Velocity is dx dt. So let's take a derivative of this. This is just a power rule. So V is going to equal to 2t cubed minus 39t squared plus, what's that, 252? 252t? Yeah, it's a fun one, Brady, isn't it? Yeah. Fun, by fun we mean tedious. Okay, this is the velocity. All right. I want to know, yeah, there's a bunch of different things we need to figure out here, because I got to figure out where the velocity is negative and also where it's decreasing. Okay, so let's find the acceleration. The acceleration is also going to be useful. Let's do that. Acceleration is another derivative. Acceleration is dv dt. Okay. So A is going to be equal to 6t squared minus 78t plus 252. That's cool. And then I think I want to figure out where the acceleration is changing. Right? I mean, do we want to do this graphically? Yeah, it's a quadratic. Oh, it is a quadratic times 2, actually. Oh, that is actually very cool. Good evening! What's up, Fanatic? How many names of time derivatives and of position do you know? So it's velocity, acceleration, jerk, snap, crackle, pop. I shit you not, it is. Wiki, time, physicists are like, they're hilarious, dude. Jounce? I don't know what jounce is. Here we go. This is what it is. Oh, jounce is snap, apparently. Yeah, okay. Yeah, so in physics, you learn, you know, position is what it is. The first derivative of position is velocity. The second derivative is acceleration. That's usually where you stop. Technically, there's a third derivative called jerk. And then after that, physics just gets silly. And they say snap, crackle, pop. And yeah, apparently snap is jounce.
That's dope.
For those that don't know what snap, crackle, pop is, it was Rice Krispie treats. It's a cereal. So yeah, some physicists came up with a funny, like, let's just name it after like cereal. Like, what? Curious, to say the least. Oh wait, what happened to YouTube? YouTube, where'd my chat go? YouTube. Why did YouTube just stop working with my chat? Damn it. I thought that jerk was usually in the context of force rather than acceleration. It's a change in acceleration, which I guess is a change in force then, no? Yeah. Okay. What is the real life application of pop? They're called moments, is what they're called. You think it's a joke on Wiki and people just ran with it? No, dude, I think it's been around. Unless that's real, that would be hilarious. I don't know exactly what's the point of the sixth moment of position, but there's something. There's something there. It's like kurtosis. Imagine making a cereal commercial and etching your elf's characters on Mantine, the language of reality. Yeah. Is it 6 and 7, dude? Stop. Okay. Well, okay. But here's the thing. You need either acceleration to be positive and velocity negative, or acceleration negative and velocity positive. Those are cases where the speed is decreasing. It's a weird thing, because speed is the magnitude of velocity. I don't know. It's a pain. I know a little bit of Hamiltonian physics. So I think we need another derivative. I think I need d/dt. So jerk. So we need jerk. Because I have to figure out the points where acceleration is changing, right? Also, I have to figure out the points where velocity is changing. Wow, there's actually a lot to do here. Yeah, no, but it's not just that dv/dt is less than 0. Because dv/dt can be greater than 0 if acceleration is negative. That's also slowing down. Machka says, I don't need d/dt. Why not? Oh, I think I see it. Yes, it's just the sine of A and the sine of V. But I need to know when the sine of V is changing. Right? So I think we set this equal to 0. Yes, okay, let's do it. So A equals 0. Well, we can factor a 6 out of this, right? So this is 6 t squared minus 13 t plus what's 252 times 6? Is that 15? Yeah, right? No. Wait, what am I saying? 6 times 16 is 96. 31. No. Yeah. 16 times 16 is 256. That's what I was thinking. Yeah, 6 times 15 is not 252. Alright, sorry. Divide by 2 is 121. Divide that by 3. That's not anything nice. What? Wait, what? Don't say it. Don't say it, guys.
Oh shit,
No,
not
no,
good.
no.
Don't do it to me. Don't do it. Please. Please. Is it 42? 6 times 4. It is 42. Okay, cool. It actually is 42. Yeah, 6 times 4 is 6 times 40 is 240. 6 times 2 is 12. 240 plus 12 is 252. There we go. All right, so what multiplies to 42 adds up to negative 13? That's negative 6 and negative 7. Ah, damn it.
Don't worry, Gold. I'll save your sanity.
You guys, they got me, dude. Okay, this is 6, t minus 6, t minus 7. Okay, fine. Fine, y'all win. All right, so let's mark some time points then that we care about, right? I care about t is 6. I care about t is equal to 7. Is there a 6 and 7 in each? I don't know. Unless you guys are like purposely finding me questions that have 6 and 7 in it. I don't know what you guys are doing. All right. I want to look at what the acceleration and the velocity is in these regions, right? Because that's where I know the acceleration is changing from like positive to negative. So let's see. When t is greater than 7, something greater than 7 minus 7 is positive. Greater than 6 is also positive. So here, let's say like acceleration. Let's say velocity, right? So here this is positive. Between 6 and 7, one of these will be negative, one of these will be positive. That's negative. And then less than 6, let's say like 5. 5 minus 6, negative. 5 minus 7, negative. It's also positive. The velocity could have zeros beyond 6 and 7. It could. But wait. Okay, so actually I do care, right? About when this thing is equal to 0. Oh, that's another good point. Yes. Yeah, Fnatic, that is a very good point. Yeah. It always alternates unless you have repeated roots, right? Because then you have the bouncing, right? That's it always crosses, otherwise it bounces. And then, yeah, that's when you get it not alternating. All right, so yeah, I think we have to check the zeros of this, unfortunately. We can factor it out. Okay, so let's do... So v is equal to t, and that's going to be 2t squared minus 39t plus 252, right? And so one of the things I know is t equals 0 is special. So here, we actually do have to move this over. Yeah, 0 is also a 0, correct. Yeah, we have to take into account 0 now. All right, fine. But also, I know the acceleration's positive over here anyways. Right, because anything to the left of that is positive. Okay. So, let's look at the velocity. I could just plug numbers in. I could be that guy. Am I that guy? Because I don't know. Wait, what factors... Oh, wait. Yeah, wait, we just... Didn't we just do this? No, this is 42 and 6, though, right? Yeah, 42 and 6 don't go to negative 39, though. Nice. Well, I know v equals 0 when t equals 0, right? So that's got to be a point. B squared minus 4ac could do it. I think we just have to solve this. Let me just get what the zeros for this thing are. I'm going to do it with the calculator. I'm lazy. It's the last stream of 2025. Okay, so let's do... let's make a graph of this. What is this? 2x squared. Minus 39x. Oh, only imaginary roots? Oh, the discriminant. Oh, the discriminant. Oh, that's actually smarter. I mean, let's just see. I'm curious. Well, yeah, wait. Oh, yeah, duh. This is huge. Yeah, plus 252. There's no way this is gonna drop. Absolutely not. Yes. The year's ending. It's been an okay year. It could have been worse. Okay, so this only has a 0 at 0. Right? So, and I'm pretty sure this is always positive, right? Just because it's massive. 2026. It's coming up, dude. It is. I don't know. Let's say like -10 to 10. The Y max needs to get really huge. Let's do this at 1,000. Let's just trace it. Yep, exactly. And we do see that on the calculator. Yep, okay, cool. So it's always positive. Yeah, we could use the quadratic form, but from what people were saying, which I do agree with, if you really want to check real quickly, you can use the discriminant, which is b squared minus 4ac, which in this case would be 39 squared minus 4 times 2 times 252. And I think you show that this is already negative. That's a TI-84. It's a gold edition TI-84 though. Yo, what's up, fam? So yeah, so this is always positive. So velocity is always positive. Great. Positive, 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 positive. So the only time interval in which the particle is decreasing is when velocity is positive and acceleration is negative. And that's going to happen here. So yes, t is greater than 6, less than 7. You guys win. Nice job. Exactly, JK. Do you guys specifically like ask ChatGPT to make math equations that the answer is between 6 and 7? Is that what you guys are doing to me? All right, Machka. Is there good physics coming up? All right, nice. Let's do some physics. Nice question by Machka.
Boom, boom, boom. Oh wait, no, I can't sing copyrighted music. You can barely get
they're not gonna detect that, dude. What?
That's dope.
No, if actually I searched it up on Twitch, you cannot sing copyrighted music, or you can actually get DMCA striked.
I hope my singing is like good enough for them to think they can like DMCA it. That'd be dope.
That's dope.
That would be, yeah, I would be amazed.
I'd be amazed, dude. I would be amazed. Ooh.
Oh, well, they added Harry Potter to Fortnite. What the heck?
Ooh, okay, dude. I haven't played any the new season yet. I need to play the new season. We're gonna do it. We're gonna do it after like today, probably. I am gonna take some time to just relax and then enjoy life, and that will include playing Fortnite with you guys.
That's amazing.
That's amazing. I wanted to play Battlefield 6, but apparently you said it was trash, right?
Yeah, for me, honestly, it has not been the best.
It's not fun anymore. Damn.
Yeah.
Damn.
I wish it was fun still, but it just became dull and it feels slow.
No, we don't like that. Y'all kids need the stimmies, dude. You need the stimmies. You like need constant stimulation. Battlefield is like takes like too much like strategic playing. There you go, Fortnite. Or Black Ops. Black Ops is just constant like.
Black Ops is not the best this year, so I haven't played any Black Ops 7 the past like probably good month.
Okay. Yeah. I think I'm done with COD until they like return to normalcy.
I think they might actually like, I don't know, you might want to try like the new Warzone because it's not half bad.
Oh, okay.
In my opinion.
I'll check it out.
But I know for damn well it's gonna make you take like 300 gigabytes just to install it, which is still nuts.
Surprise, motherfucker.
Ow. That hurts.
Yeah, for real.
All right, this is Hooke's law. I think this is okay. A thin rod of length L and mass M is placed on a horizontal table and pivoted around an axle. So wait, this is not. This is the top view. Yeah, this is always kind of funny to look at this. So yeah, they're saying that, like, for instance, let me show you. If this is top view, it's kind of like they're taking this and we're looking at it like, because the stuff is happening in this plane, but we're taking it and we're looking at it from the top. So we don't have gravity and stuff. I was thinking, I'm like, wait a minute, is there gravity here? Okay, spring width, okay, is fixed on one point, and okay, the rod is displaced a small angle theta from equilibrium and released, shown in the top view. The rod then oscillates with a simple harmonic motion at period t. What is the mass of the rod? Wow. Okay. Do you think I need to write... I'm tempted to do equation of motion, right? So if we think about... Or do I want to do torques? Yeah, this is tricky. No, this is definitely a tricky question. It's not the mass of your rod, it's how you use it. Oh god, dude. I want to say... Okay. Sum of torques equals I alpha. I know that, right? So sum of torques is equal to I alpha. Which is going to be 1/12 ml squared times alpha. But then let's look at what the torque is. So the torque is going to be... This is a force. Hear you out, Sam? What's up? Yep. I think we're going to get to that. So that force is going to be equal to kx. So torque is equal to R perp F, which is going to be equal to kx. That's the force. And then R perp. So if the force is in this direction, then I care about the R in this direction. That's away from it. And so I think that's 1/2 L cosine theta. I don't think it's sine theta. It is usually sine theta. You're right. It is usually sine theta for torque just being R cross F. But that's like the angle between this and this, which would be this. But they're giving us this angle, which is like 90 minus that, and that's why we end up using cosine instead of sine. It's more important to think of like, okay, I got a left-right force. I care about up-down distance from the pivot. Up-down distance from the pivot is this, and that's 1/2 L sine theta. Oh, sorry, 1/2 L cosine theta, sorry. Okay, so this is... Oh, interesting. Wait, but the amount that it's displaced... Oh, I think I see what you're saying. The amount that the spring is displaced, this is also like delta X, right? 60 stream streak. Oh my god, wow. Look at that, Laz. You've showed up to 60 of my streams in a row? That's intense, dude. I think the record is 100. Ethan used to show up to like every single stream like all the time. I think the record is 100. Okay. So this right here, that's R perp. That's equal to 1/2 L cosine theta. This delta X here. Here, I'll like put in green. That's equal to 1/2 L sine theta. I still don't know how the hell they're getting like these numbers. Like there's no sines or cosines at all. So I must be missing something. Okay. Cool. So then if I write this out, because alpha is the same thing as theta double dot, then I have 1/12 ml squared theta double dot is equal to 1/2, so 1/4 L squared sine theta cosine theta times K. I agree, and I think what's going to happen is we're going to make the small angle approximation. Yeah, this is it. Look at these fuckers, dude. What?
Surprise, motherfucker.
Yeah, okay. So if theta is small, you get to say that sine of theta is approximately theta, and that cosine of theta is basically equal to 1. That's hilarious. What is SHM? Simple harmonic motion. That's what it stands for. Wow. Okay, fine. Okay, so theta double dot is now equal to... Okay, so the L squareds are going to cancel. That's nice.
Good job.
So that cancels. Did any of our answers have L squared? No L squared. Proof via infinite series. Yeah, you could do that. Okay. And so this is going to become 1. This is going to become theta. And so you get 12 K over M. Theta. It's actually really cool. Okay. And then for simple harmonic motion, this is like omega squared. So omega is equal to the square root of 12 K over M. Which is cool. I mean, that definitely looks like... Oh, yeah, 12 over 4. Sorry, it's 3. Yeah, sorry, I fucked that up. Sorry. Yep, you're right. 12 over 4. Yep, 3. Sorry, 3. Thank you. Yeah, you definitely can get an imaginary part. I mean, and that's why it oscillates. You have to get an imaginary part. You love the wow sound? Yeah, it's a fun one. Okay, but then omega is equal to 2 pi over period. So period is equal to 2 pi over omega, which is going to equal to 2 pi over the square root of 3k over m. That's like none of our answers here, dude. What? Oh, we need the mass. Wait, why did I solve for this? Dude, wait, what? Why did I solve for this?
Nice.
Oh, it oscillates with the period t. Oh. What grade is this? I actually don't know what grade this is. This looks like it's College Board. So I'm tempted to say it's something to do with I see now, actually. Okay, wait. We're going to solve for M here. This is AP Physics C? Dude, this is tricky, dude. Fine. 2 pi square root of 3k over m. Okay, so you square both sides. You square all the sides. So you get period squared is equal to 4 pi squared over 3k. Let's put the m on top here. Okay, so m is equal to 3k t squared over 4 pi squared. What answer choice is that? I think it's answer choice B. This is not AP 1 physics. This is AP Physics C for sure. Is that the correct? I think the correct answer is B there, yeah. Nice. Yeah, looks good. Wow. What's the question here? This was a physics question, AP Physics question. Nice, we got it. There's the wow sound for you again, dude. E-Raven, I got the wow sound for you again. Cool Reaper, that was a fun one. It's actually random, Raven, when that plays. There's like a single button on my soundboard here that like just does positive things. So it's actually random which one it does. So if it did the wow sound twice for you, it's because it knew you were there. My question's almost there. Yes. Which one is yours? Which one is... Wait, sorry. What's your username there? I can't even see. Your username is like black. What's your username, dude? Your Ebra? Oh, Ebra. I'll do yours next, actually, just because Reaper and Gladiator, we did one of their questions already today during the stream, and I will do the other ones. Reaper and Gladiator, I'll do your other ones for sure. because the queue's not long at all. But we try to make sure we do at least one of everybody's questions first. But cool. So yeah, Ebra, hang on in. We're gonna do yours right now. It's for my test today, so I want to see if I got it right. I feel like we're getting a lot of students that have what's it like, kind of like buyer's regret today. They took something on their final and they're like, did I get it right? Did I get it right? I remember asking all my friends after taking big exams, be like, what did you get? What'd you get? What'd you get? I didn't know you're a musician. Yeah, no, I play the cello. I'm a classically trained cellist. I produce music too. If you ever want to check out my Spotify, I have like EDM cello music I play. It's just Dr. Gold. Just look up Dr. Gold. Semester's basically over. Yep. Yeah, no, this was a tricky. I wouldn't expect something. I haven't seen something like this in a while. This is quite tricky, honestly. And you had to use the small angle approximation. EDM cello. Yeah, no, it's real. Nice. Play box cello suite. Which one? There's 6. I like suite number 2. I think 2 is great. I think it's the one in G minor. Everyone knows the first one from box cello, the prelude from the suite number 1. Cello is based. Yeah, I have a gold one too. If you guys check out my Instagram, which I think is private, but you can add me. I'll let you guys. Where is it? Dr. Gold? Is that what it is? Yeah, there it is. Yeah, I got like a gold cello. I bring this thing to like Burning Man and stuff. It's super fun. Do like some little EDM cello. It's super cool. You also play cello. Sick, dude. That's really cool. Wait, what happened to my... Why is my soundboard not working anymore? The hell? There we go. There we go. It's like, where's my soundboard? I love Apocalyptica. Yeah, Apocalyptica's great. What is it? Nothing Else Matters is like one of my favorite chill, like, send the chills down the spine song. Okay, let's see. 1 minus 2 sine squared 2x plus 2 cosine squared 2x is equal to 0. Trig identities. Yeah, cosine squared 2x. Is that right, Ebra? Did I get that right? Yeah, AP exams. Okay, this is all good. Yeah. JK. Okay. Well, yeah, I mean, he is like kind of, well, almost. If this was sine squared plus cosine squared without the minus, then we would just say this is just 2. Because this would be 1, but it's not, unfortunately. Okay, that's fine. Oh, man. I think I want to convert this into sine squared, right? I think is what I want to do. Oh, the sine squared term is just x, not 2x. Oh, that's even weirder. Wait, it's like this? Really? They did this to you? Massacring my boy, dude. What the hell, dude? What? Oh, damn. Okay. Well, okay, whenever you're trying to solve these types of things, your first priority is try to make these arguments the same. So I need to know what the double angle formula is for like cosine of 2x, which I want to say is 1 minus sine squared x. Yeah. So let me. I need my trig identities. I love this. This is like one of my... Whoever came up with this thing is beautiful. 1 minus 2 cosine of 4x is 0, AJ says. Okay. I don't know if that's exactly what we want. I think I want to use one of these. You think the left term is just cosine 2x? Well, here. I will let Ebra... This is Ebra's question. Ebra, is it correct what we have written so far? Is this correct? Before I move forward? Because based on what this is, will very much change which way we go. I did the left turn. Yes, this is correct. Okay, I'm going to work from here. All right. I want to turn this into an X, so I think I'm going to use one of these double things here, which, yeah, I'm going to use this one. So cosine of 2x. Let's do the one with just sine. I think I'm going to use this one. Okay, we're going to use this. Okay. So this is going to turn this into 2, and that was cosine of 2 theta. We have cosine squared of 2 theta. A little annoying. This is going to be 2 cosine squared theta minus 1, and then squared. Right? Because I have cosine squared. It's okay. I mean, maybe you got the same answer. The beautiful thing about trig identities, bro, is there's many different ways to do this. Cool. And then I think I'm gonna convert everything to cosine. I just want like one thing. Trig is all. I like trig. What's up, Narosky? What's up, dude? Sorry, I just saw you in the chat. What's crack-a-lackin', dude?
Not much. Yeah, I've been sick.
Oh no, I'm sorry, dude.
That's why I haven't been online.
Are you feeling better now, at least?
Yeah.
Oh, good. We love that. Nice. 1 minus 2 sine squared 2x is equal to cosine 2x. Yeah, that would work if this is a 2, but it's not.
Well, it is, but I think you wrote it wrong.
Did I write it wrong?
Yeah.
No, but
Check it out.
he told me in chat that this one is not 2x.
Oh.
That's the issue.
So,
Yeah,
okay.
he typed it in wrong. Or I mean, so wait, I need to know. This is okay. The chat's like going off too much. I've been told this is also why, like, I get it. You took a test. You're trying to remember what was on the test, like, from memory. But this is also why screenshots are very important, because depending on whether that was a 2x or not, totally changes the trajectory of this question. Yes, that is correct. My bad, but that is correct. Wait, so what's correct? I don't know what's correct.
You got messed up, Aaron!
You guys. Oh, I see. Oh, I see. You guys want to use that one instead. That's fine. You can use that one as well. Okay, let's use it. Let's use it. You're right. Let's do it. Yeah, that's easier. Let's do it. I like that better. There's multiple ways to do it. It works either way. All right, let's use this one. I definitely prefer trig. Yeah, geometry is just memorizing like too many things. Okay, here we go. 1 minus 2 sine squared x squared. Because it's cosine squared, right? We're good? Good so far, guys? And then I factored afterwards.
Sorry, you want to know something cool?
What's cool?
Even if we had it written as it was given, right, with sine squared 2x plus cosine squared of x,
Yeah.
or the other way around, it would give us the same answer.
Same answer? Oh, that's cool.
Yeah. I just checked.
Oh, nice. Coolest dude says, "Hey Doc, this is very off topic, but I'm starting my own live streaming channel and website with it." That's sick, dude. How can I start streaming with a similar layout to yours? OBS? Yes, OBS is king. Every major streamer uses OBS. Yeah. There's other ones like Streamlabs OBS, like Slobs is what they call it, but I prefer just vanilla OBS. Happy to help you out. If you have me on Discord and stuff, just DM me if you have any questions about OBS. I'm happy to like answer. Because again, I've been doing this for probably almost 5 years now, and so I know all the different plugins and stuff you need to stream. Or I've figured out which ones work and which ones don't. Okay, so let's square this. So this is going to be 2 plus 4 sine to the 4th x. And then what's that? Minus 4 sine squared x. All equal to 0. You're a certified chef. That's sick, dude. Yes, but yeah, TikTok has to run through its own thing because they don't give out stream keys. Unfortunately. Yes, I can do that as well, Rex. That's easy. Okay, so then let's multiply through. So we got 1 minus 2 sine squared x plus 4 plus 8 sine to the 4th x minus 8 sine squared x equal to 0. So minus 2 and minus 8 is going to be minus 10. And then this is 8. So you have 8 sine to the 4th x minus 10 sine squared x, right? And then 1 plus 4 is 5. Plus 5 equals 0. I could factor out a 1 minus sine squared x. Plus 4 is plus 4 plus 4. No, this is plus. Sorry, I know this looked like a minus. It's a plus. Why do we not just replace the 1 minus sine term with cosine of 2x? Oh. Yeah. That actually would have been even easier.
Bruh.
No.
Yeah. Duh.
Disqualified.
Oh my god. Yeah, wait. I could have just done this one with this. Oh my god. I'm absolutely like, oh, this is bad. I'm sorry. Yes. Okay, let's go back. I mean, you'll get the same answer, but you're right. Sorry, I'm like absolutely fumbling the bag on this question. Let's do that. I just don't like cosine 2x. I always reduce the operator. I almost never bring it up. So you are right. We could use that one. And maybe had I recognized that in earlier life, would have been nicer. Yes, 1 minus sine squared of x is cosine 2x. Okay, so cosine 2x, this is much more pretty. Yeah, 2 cosine squared. 2x is equal to 0. Great. Love. So, you have cosine of 2x, 1 plus 2 cosine of 2x is equal to 0. Yeah? Beauty. Yep. So either cosine of 2x equals 0, or this equals 0. So you'd say that cosine 2x is equal to negative 1/2. If you could, how would you like to sponsor a high school engineering robotics team? How would I? I mean, I would love to if I had money.
No.
I love robotics. I did FIRST robotics all throughout college as well. Yeah. Or not college, sorry. Well, actually, I helped out FRC teams when I was in college, but when I was in high school, I did a lot of FIRST robotics. Robotics is great. I love. If I had funds, I would totally fund a robotics team. Okay, cool. What's up? I do need to hydrate. Okay. Okay, so let's do... Now let's... And what is it? From 0 to 3 pi? That's kind of fun. So that happens at a bunch of places. What? Cosine of 2x is equal to 0? Cool. So, you know that this is when 2x... So, when cosine is either pi over 2 or 3 pi over 2. And then intervals of that. So, you could say, like, what is it? Pi over 2. And then I believe it's plus pi n. Right? Because that's what's going to get you 3 pi over 2, 5 pi over 2, 7 pi over 2. Yeah? Okay, for it to equal negative 1/2, it's a little bit trickier. So, negative 1/2 happens, like here. When this is 60 degrees. So that's going to be at 120. So that's 2 pi over 3. And then it also happens, so it's going to be 2x is equal to 2 pi over 3. Or, yeah, 2 pi over 3 plus 2 pi n. Or 2x is equal to this one, which is 4 pi over 3. What's up, Amir? Yeah, we were definitely off the rip with a fun one, dude. Plus 2 pi n. Okay, cool. So then you can divide by x, because we say x is from 0 to 3 pi. That'll help us out a little bit, right? You got like 3 different cases you got to deal with here. It's kind of blows. X is pi over 4 plus pi over 2 n. X is equal to pi over 3 plus pi n. Or x is equal to 2 pi over 3 plus pi n. And then you got to check all the solutions for n is, for x is at least between 0 and 3 pi. So when n equals 0, n is like any integer. Yeah. The reason for that is that most trig things are periodic every 2 pi n. So if you add 2 pi, you add 4 pi, you add 6 pi, you get the same thing. Because 2 pi is 1 revolution. So n is just like a number. You did the first case wrong? That's okay. So, I mean, you'll at least get partial credit, right? So, when n equals 0, so here let's just do the n's. We'll do n equals 0. So that's going to give you pi over 4. And then you're going to get pi over 3. And then you're going to get 2 pi over 3. Let's do n equals 1. That's going to give you 3 pi over 4. This is going to give you 4 pi over 3. Right? And then this will give you 5 pi over 3. Right? And then, what is that? Ooh, you get 5 pi over 4. Dude, there's so many of these, dude. What? She wants you to go all the way to 3 pi? Ew. Bro, that's so many cases. I don't want to do that. Wait, what?
I did it for you if you want to check.
Oh, thank you. All right, I'm going to take Norowski. Thank you, Norowski. Yeah, I don't want to fucking add all these. That sucks.
I recognize this problem. I think I did it too when I was in 9th grade.
Oh, okay. Here we go. All
Yeah, I
right.
recognize it.
Okay, Norowski has saved me a lot of anguish and mental stability, and he's gone ahead and computed all the ones that would be it. So yes, it would be this: pi over 4, 3 pi over 4, 7 pi over 4, 9 pi over 4, 11 pi over 4, right? Because once you go past 12 pi over 4, you can't. That's bad. 12 pi over 4 is that. Okay, cool. And this is 4 pi. This is pi over 3, 4 pi over 3, 7 pi over 3. You can't go past 9 pi over 3. And then 2 pi over 3, 5 pi over 3, 8 pi over 3. Sick. Nice. Good job, everybody. Fun question from... Who was that? Ebro. Nice, Ebro. I guess actually, I was almost done. I should have just like kept going. Well, whatever. It's just like... Here, I'm just gonna put like ... I'm tired. And then we can say, but Norowski is not. 5 pi over 4 seemed conspicuously absent. Wait, did I fuck that up? Wait. Did I? Yeah, wait. I think we are missing 5 pi over 4, no? Why is 5 pi over 4? That should work. Yeah, right? Yeah.
Oh, yeah, oops.
Oopsies. It's okay. Alright. All good, Ebra. Good catch, Fem. Fem's always got it. Fem is our solutions manual. Oh, wow. We got a lot of questions coming up. Oh, my God. Okay. All right, Ebra. Nice. I'll post the solution for this in our Discord, Ebra, by the way. So if you ever want to check it out again, it'll be there. Just make sure, go to the website. Yeah, I totally can. I'm Null. Yeah, you're very welcome, bro. So I'm Null. If you wanna submit a screenshot to the website, there, actualofficehours.com. We'll go over any. If you have like a practice question or like a practice like test or homework or something, I don't know. Probably help you out with it. So I got discrete math 2 next semester. Are you familiar with it? Not really, but I'm not the only person that does this, and so yeah, I'm always very keen. So if you go to the website actualofficehours.com and click on the streaming schedule, it's a little light right now because it's Christmas and like no one's really streaming, but there are other streamers that do like higher level math than I do, and so one of them is Zach, for instance, and he's E2IPi. So if you look later on the calendar here towards the new year, this is his. It's E2IPi. If you click on his Twitch, he can probably help you out with discrete math. What's the site? Actualofficehours.com. There's a link. It's right there. It's right there. Actualofficehours.com. It says it. You can't chat in my Twitch? Why? I don't know. I'm grade 12 Ontario as well. We should have had the same curriculum. Cool. All right, what was in the queue? There's a lot now. Wait, Ebra, didn't we already do this one? Wait, why is it in the queue twice? What the hell? Oh, I need to delete 3. That's why. Okay, there we go. All right. Do I want to do one of Reapers real quick? Oh, I don't know, Alistair. Maybe it thinks you're like suspicious. Okay. We got a lot. All right. Let me have like a say. And this always happens. We just start like getting tons of questions coming in. Graph using technology. All right, I'll do a couple of these, Kasei. Yeah, good luck. Yes. Also, feel free, join the Discord, add each other. Be social. All right, Kasei, the depth of water in a harbor varies as a function of time. The maximum depth is 9, minimum is 1. Cool. This is sinusoidals. So max equals 9, min equals 1. Period is equal to 12. So omega is equal to 2 pi over 12, which is equal to pi over 6. If the depth is 5 feet at midnight. Oh, that's actually cool. 5 feet is the midpoint, right? So here, the mid is equal to 5, because that's 9 plus 1 divided by 2. And it's increasing. That's actually really nice. That tells us it must be cosine. No, sine. Must be sine. Yeah, midline is 5. Yep. Create an algebraic model to predict as that. Yep, cool. All right, so amplitude is going to be equal to 4, because you're going to do 1 plus 9 divided by, 9 minus 1 divided by 2. And then, so we're going to say 4. This is a sine function, because sine starts at the mid when it's equal to 0. This is why it's important to kind of just understand what sine and cosine look like. It'll help you out a lot. So 4 sine, and then this is going to be pi over 6t. There's no phase shift because it starts exactly where I want it to. And plus midline, which is 5. So there you go.
Oh, yeah.
That's your equation. If any of that doesn't make sense, please let me know. I'll go through it real quick. All right, and then they say do something with technology. The boat must be at least 7 feet to navigate the harbor. She wants to enter the harbor during the afternoon. Create a graph of this function using tech. Well, we love tech. All right, let's do it in the calculator. Let's do it in the gold calculator. All right, so we're going to go to y. We're going to type in our function, which is 4 sine. Also, make sure you're in radian mode, not degree. So we got to be in radian mode. 4 sine pi over 6 t, and then plus 5. Heart, rose, kiss, rosy, cute, congrat, thanks. Oh, that's what the emojis showed up as text. That's hilarious. Thanks, Zanman. Okay, there you go. All right, and let's set our window appropriately. So we're gonna start at midnight, and I think they said every hour is T. So, yeah. So our maximum is gonna probably be 24, right? Because we're gonna go from midnight to midnight, 24 hours. Our minimum, well, this is, we know what our minimum is going to be, right? Our minimum is going to be 1. Our maximum is going to be 9. That's our Y max. So then you can just like graph this and it'll do it. Look at this. This is beautiful. This is so sick. Okay. And if you want it to be at least 7 feet, what you do is then you put in another graph equal to 7. And here's the cool thing. You can actually like make this graph like look fun. Let's make it like a thick line. There you go. There you go. So that tells you all the different times where it's going to be greater than 7. Dude, the calculator is so fun. This is beautiful. I love this calculator. Okay, cool. What's the earliest and how long can she stay in the harbor? This is cool. This is where, like, dude, math is real, man. Okay. What's the earliest time? I assume we're allowed to still use technology to solve this, right? I mean, I could, like, set it equal to and do it by hand, but it's so much cooler with the calculator. So the earliest she can arrive at the harbor is, like, this point right here. So we can actually figure out where that is using the calculator. You're gonna go to second calc, and you're gonna say intersect 5. And then you got to pick, like, where the first curve is. So we can say, like, first curve is here, second curve's here. You got to guess, like, kind of where it is. And that's going to tell us the intersections at x equals 1. So the earliest time she can enter the harbor is at 1 a.m. And then how long can she stay in the harbor? Okay, so let's calculate the other intersect. So we're going to go over here. Guess the intersect, and that's going to be 5. So 1 a.m. to 6 a.m. Right? No, 1 a.m. to 5 a.m. Sorry, because it's T is after midnight. Midnight's like 0. Okay. So she can stay 4 hours in the harbor. 4 hours. Nice. Yep, that's what it is. Good job, guys. Good question, Kasey. I like that. It's kind of a fun one. Nice. Okay. Let's see. Reaper, I'll do your other one. You've been waiting for a little bit, and you are next on the queue. More physics, it looks like. Okay, a solid disk of mass m and r is speeding with an angular speed of that. That's rotational inertia. A brake is pressed, and a force. Okay, if the friction between the disk and the brake slows the. Okay, it comes to the stop in 2. Oh, this is actually kind of cool. So this tells me right away if it comes to a stop in 2 full rotations, that delta theta is equal to 4 pi. Right? Again, this kind of connects to what we were doing before. When you guys were talking about like 2 pi n, right? 2 pi is a rotation. So 2 rotations would be 2 times 2 pi, which is 4 pi. They want to know the coefficient of kinetic friction. Wow. Okay. All right. I'm going to use this equation, which is that omega squared is equal to omega naught squared plus 2 alpha delta theta. Is the jump from high school physics to university physics super huge? I don't think it is. Especially if you're taking AP physics, it's actually kind of the same. I would say AP physics is very similar to university physics. The difference is at the university level, it can start getting really hard really quickly. We could use energy. I think I'm going to use this though, Fem. I know alpha. We know that torque is equal to I alpha. And so then torque, so I can say like RF perp over I is equal to alpha. And I think we're going to solve for alpha because I know it has an initial angular speed of omega naught, and then when it stops, that means omega is going to go to 0. Yeah, so this is actually really cool. So, and then, right, we know that this is just equal to 4 pi. Cool. All right, so at the end of the day, if I move all that over, I'm going to get that negative 8 pi alpha is equal to omega naught squared. Alpha is going to end up being negative in order for this square root to like work out. And then alpha is equal to RF perp over I. So negative 8 pi RF perp over I is equal to alpha. What are they asking for at the end of the day? Coefficient of friction. Okay, cool. And then F perp is going to be equal to mu k Fn, where Fn in this case, with a brake, right? So here's what's happening. So the brake is being exerted on the disc with a force F, big F, and by Newton's, whatever, third law, equal opposite reaction, that means the normal force between this and the brake is going to be also equal to big F. Yeah, omega naught squared. Yeah. Wait, what did I write here? Sorry, by the way. What the hell did I do? Say thank you. Yeah. Oh my god, I hallucinated. Yes, thank you. Thank you. Oh, okay, cool. All right, so F perp is just equal to mu k big F. So now let's just solve for this. So I think this is an I is equal to 1/2 mr squared. Big M r squared. And then this is an R. Hitman, what would you suggest if we came across a physics question, an analysis without numbers, or dive straight into the question with numbers? I think you should always keep things in variables as long as you can. Because you'll see things that cancel. Like, for instance, R squared and R, one of these R's is going to go away. You don't want to, like, start plugging in numbers right away. And then this is mu k F. So I have negative 8 pi mu k F. And negative 8 over 1/2 is going to be negative 16. And then we're still going to have a big MR on the bottom. And then this is equal to omega naught squared. Yeah, numbers make things super messy. So now just solving for mu k, eye on the prize, baby. Let's solve for this. We just got to move this over, divide by this. So we get that mu k is equal to omega naught squared MR over negative 16 pi F. Where do we got it? It should be negative, though. Oh, wait. Acceleration's gonna be negative, or sorry, F is negative, right? Yeah, okay. Whatever. Get rid of the negative at the end of the day. This is one of these physics things where we're just like, you just wave your hand and you're just like, oh, well, coefficient of friction can't be negative, but the force is technically negative, so that's where it comes from. Yeah, this is technically negative. Okay, omega naught squared M. So I have an M on mine. Okay, there we go. Omega naught squared M. Oh, I have R over negative 16 pi F. Well, I don't know where G comes from. Wait, why are they putting gravity on there? No, there's no gravity. This is wrong. Oh, there it is. There we go. MR omega naught squared over 16 pi F. Yep, cool. There we go. That's it. Answer choice A. A it is. Yep. Cool question, Reaper. Bum, 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 nice. Okay. We're going to throw that in the Discord. Yeah, AP Physics C, dude. These are toughies.
I don't know if that would be a multiple. I don't know if that would be a multiple choice question on an AP exam. That could be like a free response question. That's a lot for multiple choice. Yeah, I wouldn't do that. That's like way too much. Alright, what we got next on the queue? Gladiator. Ooh, nice. Doing a lot of physics today. I'm not complaining. I like physics. Yeah,
It's the same thing. It's 1/2 I omega squared. But it would have been the same thing, right? And then it would have been torque times 4 pi, right? Torque. I think 1/2 I omega squared has to equal to torque times rotational distance or something. Isaac Newton says, I'm a junior in high school, interested in engineering. What should I do? See if you can get on a robotics team. Robotics is dope.
That's
I would just say, like, getting any sort of experience in high school that you can will look great and also teach you a lot of cool little skills for getting into engineering. Like, do some practical stuff to make sure you like engineering. Do you have a robotics team, or is there like a robotics competition you could join somewhere? Robotics is great. It's like the ultimate engineering like activity. Yeah, cool. Okay. What the force on the one the oh, this is a level 3 problem. Is shown. What is the magnitude of this force? Wait, do I know what Q is though? Do I have any clue what Q is? Our team won state, so I don't know if I can compete. Also, you don't have to do the big competitions. They have like side ones. Like I think Vex Robotics still does stuff, or like Lego. How do we go from lo-fi to jazz? I don't know. Just it's whatever the Suno stuff wants to do. You can always join a team though, Isaac. Oh. This does tell me something, actually, right? If the force is straight down, that means the sum of the forces in the x direction is 0.
Oh no.
Yeah, we can work out what Q is. Damn. Fine. Okay. Alright, so between these two, that's going to pull it this way. So we could say sum of forces in the x direction has to be equal to 0. So that's going to be K times 10 times 10 to the minus 9 times 1 times 10 to the minus 9. And this is negative. This is pulling it to the left. And then r squared, well, this is a 30, 60, 90. It's unfortunate because, I mean, man, this isn't going to be... Well, yes. Isn't this 5 over 2 then? What's up, Lucky Cat? What was my major? Physics. Physics is great. Yeah, okay. Because this and this and this is 90. So that's going to be 5 cosine of 60. This is 5 cosine of 60 degrees. You should remember the cosine of 60 degrees is 1/2, so this is just equal to 5 halves. Okay, so then this is 5 halves squared plus KQ. We don't know what Q is. I know Q has to be probably positive though, right? Because this thing needs to pull it this way. And that's other 1 times 10 to the minus 9. And then that distance, this is going to be 5 cosine of 30 degrees. Which is equal to 5 squared of 3 over 2. Cool. Yep. You're right, Vanny Cobra. You're right. Alright, and these have to add up to 0 because I need the net force to be just down. So the nice thing is I can just start canceling some stuff up. This is why we don't plug all the numbers in right away, right? Because look, K will cancel with K, 1 will cancel with 1. And then you're just left with 10 times 10 to the minus 9 is equal to Q. And then this is going to be over 75 fourths, right? Is that 75 fourths? So 4Q over 75. If I square this, right? I get 25, I get another 3, and then I get a 4. You're right, I didn't take the X components yet. Fuck. No. Damn it. Yes, you're right. Yes, that's just the forces. Okay, you're so right. So right. Okay, well, I mean, the K's and the Q's will still cancel. That's okay. That will still cancel. All right, there we go. So yeah, the X component of this will be whatever that force is, and then that's going to be this force times the cosine of 60 degrees. And then this will be this force cosine of 30 degrees. Okay. We're back in business. That's cool, because this was actually also 5 cosine of 60. 5 halves. Right? It's actually kind of cool how that works. Yeah. Alright. This still cancels, and this cancels, and this cancels. Cosine of 60 degrees from before is equal to 1/2. Cosine of 30 degrees is square root of 3 over 2. This is ugly. It's just not nice. I don't like this. Alright, 10 times 10 to the minus 9 over 25 over 4 times 1/2. Right? I don't think it's just strictly 10 times 0.5. Needs to equal Q. And then that's going to be over 75 over 4. And then that's going to be square root of 3 over 2. Just an ugly mess, dude. I wonder if we could use this to find the sine one. No? Is there not an easier way to do this? The distance r to the top charge is the same for both lower charges, so k and r squared will cancel. Oh, you are right, actually. Yes. But let's get Q first, right? Don't I need to get Q? So 10 times 10 to the minus 9, and then that's... Ooh, Norosky has an opinion. All right, here. Let me just take Norosky's just because I don't want to trudge through the algebra here. Just terrible. Let's see Norosky's opinion. You're using tangent. Okay, R12 is h sine 6. Oh, okay. You're gonna call this distance h. Okay. Okay. That's clever. So R12 is h over sine 60. Okay. F12, yeah, pulls it down to the left. So that must have pulled down to the right. So F12 is, yeah, this. Yep. You did it faster than me. Did you ever solve for Q, though? I don't think you ever solved for Q, though.
Oh.
No, you don't have to. No, you're right. This is actually clever. Because you just said that the forces... Yeah, I get it. You're saying that This is actually really clever. Right, you say that this force has to equal this force, right?
Yeah.
And
So
then
you don't have to compute.
so you don't even have to solve for Q. Wow, that's clever.
Oh yeah.
Oh wow. I like your solution. I think your solution's cool. 9.35 times 10 to the minus 5, yeah. Yeah, this is very cool, Narosky. This is what would we say, elegant? This is like brutal. This is because like I'm gonna solve for Q and then I'm gonna plug it back in and put these as like signs, and then I'm gonna resolve.
Yeah, if you can like, I mean, if you're good with like calculations, that's quicker, right? The way you were doing it, I think that would be
Right.
quicker.
I want to see if we get the same answer.
Perhaps,
Actually,
yeah.
I'm curious if we get the same answer. I really want to see. Actually, I bet we
Okay.
do.
Yeah, we have to.
We have to, right? There's no way we don't. 75 over 2. I'm seeing a lot of things that cancel at least. This is actually really cool. This cancels with this. And then that's going to get me another over 3. So actually maybe I might start seeing the same thing. Wait, so 10 times 10 to the minus 9 is equal to Q squared of 3 over 3. Is that the 0.866 you're talking about, Veiny Cobra? Let's see. Okay. 10 e to the minus 9 times 3 divided by the square root of 3 is 1.73 times 10 to the minus 8. Oh, so I get kind of a different answer here, though, dude. I get 17.3 nanocoulombs. You got 5. I don't think it can be 5, though. Right? I mean, let's think about this, right? Veiny Cobra. This thing is further away. And it's also further away in the x direction. Sorry, this thing is further away in the x direction, right? And so in order for it to pull with the same force that this does, it has to have more than 10 nanocoulombs. I think this is okay. So I think Q equals 17.3 times 10 to the negative 9. What's up, Yusuf? Okay, so then sum of forces in the y direction is gonna be this same thing, but like, right, Veiny? Yeah, right? Yeah. Okay, now we need to not get rid of all this, because then this is gonna be sine of 60. So, sum of forces in the y direction, this is gonna be sine of 60 degrees. This is gonna be sine of 30 degrees. And then we're gonna plug this in that. And they're not opposites, right? Now they're both pointing in the same direction. Oh man, this is ugliness. Fine. I'm gonna pull the K out. I'll multiply everything by K eventually. Okay, let's do this. 10 e negative 9. I don't care. Oh, actually I do care. Yeah, times 1 e negative 9 divided by 5 over 2 squared times the sine of 60 degrees. Oh, and let's make sure we're in degree mode. Uh-oh. You gotta be careful about this. Sine 60, good. And then we're gonna add that to 17.3 e to the negative 9 times 1 e to the negative 9 times the sine of 30 And all of that is divided by the most horrific number ever. 75 over 4. Okay. So I get that. But then I'm going to multiply this by 9 e to the 9. Because that's what k is. And I get 1.66 times 10 to the minus 8. Uh-oh.
Oh shit, not good.
Oh, so I probably fucked up.
Wait, what did you get for Q?
17 times 10 to the minus 3. Sorry, 17.3 times 10 to the minus 9.
Yeah, that's okay.
Oh, okay. Well, I did this wrong, apparently. Sadness. What did I do wrong here? The calculator. So you got that charge as well? The charge is right? Yeah? What the hell did I do
Yeah,
wrong
I
there?
think so.
The fuck? Plus that times that. Yeah. Times. I get 1.62. .66 times 10 to the minus 8. Seems kind of low. You got 10 to the minus 5. I'm tempted to say that's better. When in doubt, we'll chat GPT it out, see what it says.
I think ChatGPT gets this wrong. I'm pretty sure
let's see.
he's gonna get this wrong.
You think it's gonna get it wrong? Let's see. Come on, Clanker.
Yeah, and I know why. I think I know why.
Because of the diagram.
Yeah.
Yeah.
Gemini, I'm not sure.
All right, the clankers are gonna compete against each other.
Yeah. Let's see.
Let's see what they got. Chat's still analyzing the image.
Wow,
They got
this guy's fast.
9.4 times 10 to the minus 5.
Yeah, that's nice.
Is that what you got?
Yep.
Yeah. Okay. Did they get the Q for it? I'm curious if they got the Q. No, they just did it with the forces. They never found the unknown charge. That's actually really cool. They did it your way, Narowski, by the way. Yeah.
Nice. I'm curious what ChatGPT gets.
Chat gets it so wrong.
I was so sure.
Oh man. Okay.
And
Alright.
and I know why. It's cause he ChatGPT treats the whole hypotenuse as being 5 centimeters.
Uh-huh.
That's what he gets wrong. Right?
I
so
see, I
the
see.
distance between Q and the negative one. Not the negative one. Between
Let's
Q
correct
and
it though.
The 10 and C1. No, it isn't. It isn't.
Is it? It is. It is 5 centimeters, isn't it? Between the Q and the
No.
10.
No.
No, not the
It's
negative
between-
one.
Yeah,
like
it's
betw-
between Q and the height is 5 centimeters.
Oh, wait a minute. No. Wait. This whole distance isn't 5?
No.
Oh shit, not good.
I think it's between Q and the perpendicular.
That's misleading. That is misleading
No?
as a question. You no, I mean, I will agree with you, but my gut instinct is that these were 5 centimeters apart. Yeah, Femvox says I figured the 5 was the whole base. I agree.
Like the way it's positioned, it makes me wonder if
Yeah, if that's
It's
true,
the
that's
whole
totally
base
crap, dude. Yeah. You can't do that. You got scammed. We all got scammed.
I mean we have two solutions, right? So
Yeah. In any case, like my solution is like absolute trash.
yeah.
Yeah, they wrote the 5 halfway between the charges. Yeah, I'm tempted to say that. I think the 5 has to be the whole thing. I think it does.
Well, if it is the whole thing, then GPT gets it right, and if not, then I
And
got it
Gemini
right.
gets it right. Oh, fascinating. I mean, I got it wrong either way, because, like, apparently I can't, like, add math here or something. Okay. I have 40 minutes. We still got 7 questions in the queue, so I'm gonna... I'll punt this one a little bit. I have a chemistry final tomorrow. I hope some of your smarts bless me. Bless you, Bryson, dude.
Oh, yeah.
Good luck on your chem final tomorrow, by the way, Bryson. Alright, Gladiator. That was a fun one. Well, not fun. It was actually kind of tedious.
You're not that guy, pal. Trust me. You're not that guy.
That kind of hurt me, that question. Okay, next up is going to be Tavia. Tavia, what do you got for me? Hopefully something nice. Something nice. Thanks, man. I hope it won't be too hard. Mostly just math equations. What are you going to have, like rate law stuff? Maybe some stoichiometry? Tavia. Ooh. No one ever knows how to rotate their photos, but it's okay. Oh, PVNRT? Okay, ideal gas law. Yeah, you're good. You got it set, dude. And I'm always going to do this because, like, otherwise it fucks up. What is the electric field at the center of the square if Q is equal to 1 times 10 to the minus A and A is equal to 5? Ooh. So electric field... I think it's just sum of KQQ over R squared, no? Yeah, because you imagine that there's a test charge here. Yeah, okay, so E is equal to the sum of KQ over R squared. But then it's annoying, but this, I mean, this is really technically R third, and then it's like R vector. Yeah. So, are any of these going to cancel? They say it's only in the Y direction. Let's see if I agree why that's true. So let's see. You're going to get negative electric field here. Positive electric field there. And then you're going to get positive electric field here. And then negative electric field here. Oh, okay. I think I see what happens. Yeah, okay. This is actually really cool. So yeah, in terms of the X direction, these two will cancel out their X components, and these two will also cancel out their X components, Tavia. So yeah, you only have to deal with the Y. Nice. That's actually not too bad. Okay, yeah. So you can say that, like, X components of E cancel. Because you got pairs. Right, you have this and this. And then you have this one and this one. Will the Y components cancel? Not quite. These ones will push it down. These ones will push it up. So, I wonder if there is another, like... I just studied this. How does TikTok know? The algorithm, dude. They analyze everything I say, and then they go find people that have this in their tests or something. Alright. If A is equal to 5, then this is 5 root 2, right? Or no, it was root 5. Wait, fuck. Yes, 1 root 2. This is 5 root 2, so this is 5 root 2 over 2. Is this distance, right? Oh, net ionic equations? Yeah, those are fun. That's a little bit of math. Just gotta balance the electrons or something. Okay, so this is giving me flashbacks. Yeah, seriously. Alright, this is 5 root 2 over 2. Yeah. You can say R is equal to that. Okay. It is E&M. I would say it is kind of foundational E&M. Okay, so you have these two that are adding up. And then you need the component of it in the up direction. So that's going to be sine of 45 degrees, which is going to be square root. Dude, there's so many fucking square root of 2s happening. Okay. For y components, Fy is equal to F sine 45 degrees. And this is going to end up being square root of 2 over 2. Oh, thanks for the laughing disco. 250 joules. Nice, bro. Thank you. Okay, so F, or you could say sorry, EY. It's not F anymore. They're related to each other, though, right? You learn that, like, F equals QE. So F over Q is equal to E. And that's why, if you imagine this is a test charge Q, and you would figure out the force is KQQ over R squared, this Q cancels out one of the Q's. That's where it comes from. Okay. So this is 9 times 10 to the 9th times 2Q over 5 square root of 2 over 2 squared. That's cool. And then there's actually, so that's from one of these things, but then I have 2 of them. So I'm going to put another 2 here. And then sine of 45 is going to be square root of 2 over 2. Now, that electric field is pointing up. But then you have minus the electric field from these, which pull down. And those are going to be pretty similar. You're still going to have 2 of them. But now the charge is just Q, not 2Q. Okay, is there something nice here to just simplify this? We can factor a bunch of stuff out, right? Because this is 4Q minus 2Q, so you're just going to get 2Q eventually. So you're going to get 9 times 10 to the 9th over 5 root 2 over 2 squared. Square root of 2 over 2. And then this is going to be 4Q minus 2Q, which is going to be 2Q. Okay. And I wonder if this actually comes out. And then Q is 1 times 10 to the 8th. Yeah. I'm doing a lot of, like, math, algebra simplifications, which I might be fucking that up, honestly. But okay. I think one of these square root of 2 over 2's will cancel with one of these. So we're just going to be left with 18. So wait, 9 times 10 to the 9th times 2 times 10 to the 8th. So what is that? That's 18 times 10 to the 1 over 25 square root of 2 over 2. Okay. It's actually not so bad. So 180 over 12.5 square root of 2. Let's see what that is. Okay. 180 divided by 12.5. Square root of 2 is like 1.4 or something. And I get, oh man, we're off by a factor of 1. I get 10.18. 10.18 newtons per coulomb. But they want 1.82 times 10 to the 5th. Oh, ew, what?
Surprise, motherfucker.
Oh no, we're like so off. Oh, because A is in centimeters. Oh. I need this in meters. I see. Okay. So I need an additional 0.01 squared. Oh, so that's like times 10 to the minus 4. Uh-huh. Uh-huh. Yeah, wait, one sec. But forgot. Centimeters. So, so 10.18 times 10 to the minus 4. That's what I'm gonna have to be careful about. Yeah, yeah, G to pounds and stuff. Yeah, dude, this is so much, dude.
Bruh.
You done messed up, Aaron.
That still doesn't really help me out though, because I want times 10 to the times 10 to the 5th. Oh, is it times 10 to the 4th? Oh yeah, because if you're dividing by 10 to the minus 4, you multiply by 10 to the 4th. Okay. Okay, then we're in business. So this is 1.018 times 10 to the 1 times 10 to the 1 times 10 to the 4, and that equals 1.02 times 10 to the 5th newtons per coulomb. Yes. There we go. That's the correct answer. Bingo.
Bing bong.
Yeah. Nice. Love that, dude. Yeah, that was actually really fun. Here, I'm giving myself a little celebration.
Whoa! Damn, man, look at that, look!
Because I had to do a lot of algebra in my head, and I was hoping it was going to work out. And it did. Deserved. Thanks, bro.
Next week.
Alright, let's see. That was Tavia's. I'm getting kind of hungry. Boom, 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 boom. Let's see. Let me make sure I do one of each. Oh, wow. That's a lot. Wow, there's a lot of questions here. What? If you want a fun one, do Dave's. Yeah. I mean, these are all fun. This is from, who's this? Who submitted this one? Black and Dillo? What is this? Tell me, Black, whatever, like, which question you want me to do. I mean, there's 8 of them. I can't do all 8, unfortunately.
Oh shit, not good.
That would take me a while. Tell me, like, which one you want. If you're still watching the stream. He wants all of them? Well, I can't do all of them. Black and yellow, black and yellow. Which one? Pick one of the numbers. This is kind of funny. Find the measure of AFB. AFB. So I want this angle. If AB equals BC. Let's just mark these. Okay, so wait. AB. Oh, there are a bunch of isosceles triangles. AB equals BC equals CD equals DE equals EF. Whoa. Whoa. And ABF is isosceles. How'd your physics exam going, Flip? Oh, it's a Christmas tree. It is. It is a Christmas tree. Okay. Tavia, which one do you want me to do? Oh wait, I did Tavia's. Sorry, black and yellow is who I was asking about. Yeah. Yes, you're welcome, Tavia. This one was kind of a heater, honestly. Like, there's a lot going on here. It's just kind of annoying. You have your physics test tomorrow. Oh, best of luck. If you stick around, I can probably do one of your other ones. Let me just see if I can make sure I get at least one of everybody else's. Okay, let's see if we can do this one. I think I can get this. Wait, where is it? There it is. Nope. Here. There we go. Okay. This is isosceles. Ooh. Is there like a bunch of inscribed triangles here, maybe? So what? So this angle equals this angle? And then triangle EDC could be a 45, 45, 90. I wonder. Well, we know this equals this. Right? And then we know Well, that's crazy, Flip. Wait, you had all of that in one physics exam? You had all E&M and mechanics? That's a lot, dude. What?
You done messed up, AA Ron!
Usually you just have one. Quantum mechanics? If you send a screenshot, I can try it. I can try to do some quantum. Find the measure of AFB. Anyone have an idea for this one? Oh, AFB is also isosceles. Oh, wait a minute. Wait a minute. So wait, that means also that this angle is the same as this angle. Right? Oh, wait a minute. Oh, and that's funny. Wait, well, this is such a funny one, dude. Wait, what? Oh my god, this is like screwing me up. Because then also, this angle's equal. Wait, not blue angle. Sorry, I'm running out of colors. Okay, this angle is equal to this angle, right? What gets you prepared for university? Okay, great. The blue angle and the purple one. I almost want to come up with numbers for these. Start at the top and work your way down. Okay. I think I see. Okay. Because this and let me just call this let's just call this X, because that's what I'm looking for, right? So I know 180 minus 2X is equal to Y, right? And then but 180 minus Y is equal to Z? Oh, okay. So that tells me this angle is twice this angle, yeah? Right? So 2X is equal to Z. That's kind of cool. And then this is Z. I don't know. I'm running out of letters. Let's call this like... let's call this maybe like W? Energy momentum was low-key hell. Uh-oh, I'm sorry. What's the answer you're trying to find? You're trying to figure out this angle. You're trying to figure out X. I'm just like running out of like letters for things. I don't know, like let's call this like J. Now attack the brown angles. Right, okay. And then we want to call this K, and let's call this L. Let's just keep going. Okay. Thank you, Narosky. Ooh, how is it 3U? How'd you get the 3U? Okay, wait a minute. Oh, I think oh, okay, wait. Yeah. Okay. So
Do you see how?
I see it. It's actually really cool. Yeah, get these just all in terms of X. I get it. Okay. I get it. You're just gonna say everything. So if this is 2X, And then this is 2x. And then this is x. And then this must be 180 minus 4x. But then this plus this must equal 180. So 180 minus 3x plus like question mark equals 180. Okay, so then this is 3x. Oh, that's fucking cool. Oh, fascinating. And then this is 3x. Okay, and then this is 180 minus 3x. So then, okay. We can get this. So that's going to be 5x then? No. No, wait. 180 minus 3x plus 2x plus question mark equals 180. Cancel. Oh, so this is just x. It's x again, no?
I think that's 6x instead of 3x. Because you have 2.
Wait. This is 2x.
Yeah, but you have like 3x. Like in your brown triangle.
Oh, 180 minus 6x. Oh, you're right. You're so right, actually. Yeah, Yep. Let me go fix that. Yep, you're right. This is 6x. Yes! Got it, okay. Okay. So this is 4x? Wait, yes. Yep. Okay, so this is 4x. Okay. And then, can I use this property, right? So that 8x plus... Well, okay. Oh, but this is 4x as well. Oh.
Yep.
Oh, okay, wait. So 180 minus 8x, which is this angle, plus 3x has to equal 4x. Oh, okay, so 180 is equal to 9x, x equals 20 degrees. Oh, that's brilliant. Nice. Oh, man. That's super cool. I like Naroski's solution better. Yours looks a lot cleaner. Naroski, I know you're in there. He is here. Look at that. Look, this is so much more beautiful. Naroski. What's happening to the sounds? Got any good math problems I can work on? Alistair, there's a bunch in there. Okay, nice. This was... Whose was this? I think this was Dave. Nice, okay. Good question, Dave. I liked it. That's a cool little fun little puzzle. I wonder if there's a property of that. All right, post Dave's. Delete Dave's. Let's see, pi. Ooh, wow. Something with pitch. Okay, I assume they want us to do this problem number 12. All physics and chem left, yeah. And then Lucky Cat's got chem. I'm waiting for black and yellow. If you're in our chat, black and yellow, can you tell me which one of your questions you want me to do from here? There's a lot going on here. I want to know which one you want help with. Okay. No pure math, not today. Okay. Magnetic field, the angle between the magnetic field and the velocity is the arcsine of 0.9. Show that the path of the particle will be a helix. Find the diameter of the helix and its pitch. Oh, okay. I like if they give me arc sign, dude. What? Okay. And I think pitch is like how much it goes in one revolution, I think. Is that what pitch is? It's like over one revolution, like what's like this angle, I think. I think that's pitch. Okay. Okay, velocity's that way, and the angle between... So, this is what you learn. You learn that F is equal to Q V cross B. And wait, is it in an electric field? No, it's just in a magnetic field. I see. Oh, okay. So, this... The force acting on it will always be perpendicular, like, to cause it move in a circle. To cause it to move in a circle. But some of this initial velocity will not change, and that's the amount that is parallel to B. So velocity parallel to B does not change. I know multivariable. But velocity perpendicular to B causes cyclical motion. So what ends up happening is you're going to have something doing this, like moving around in a circle, but it's also going to be like processing to the right. Okay, cool. I wish the stream lasted. Here, I'll add some more time for you guys. Yeah, it's okay. I don't have anyone else today. I'll add more time. I'll add another 30 minutes. But then I really want to eat. I'm getting hungry. I think I'm getting hungry. I'll give you guys a note.
I just got an email.
What'd you get the email for? What was up?
So I participated in a competition, like an international one, and I just got the results.
Ooh, how'd you do? Tell us.
I don't know. I'm scared to open.
Oh. You want to do a live reveal? You want to do a live reveal?
Yeah, sure.
Yeah, let's do a live reveal. Let's do a live reveal of his things. Norowski's a very smart math person and physics person. He competed in math and physics competition stuff.
Okay, so there I have to log in. Hold on.
Okay, he's got to log in.
Yep.
Yes, Fembox says, good luck. Yes.
What problems do they throw at me? I can actually give you the problems.
Ooh. Oh, they have them released too?
Yeah. 1 second.
Okay.
Oh, actually, no, I don't think they have them posted, but I do have the problems.
Mm-hmm.
1 second. Let me search for them first.
Okay. All right. QVB sine theta, I think is how this works. Yeah. Right. Okay. So whenever you have velocity that is perpendicular to a magnetic field, that causes a restoring centripetal force to cause it to move in a circle, and that force is equal to QV cross B, which is the same thing as QVB sine theta. That is also equal to the mass times acceleration, which for something moving in a circle is centripetal acceleration, so that's gonna be mv squared over r. So what you get is that QVB sine theta is equal, it's centripetal, not centrifugal. I don't like centrifugal. mv squared over r. Okay. One of the v's is going to cancel. And what are they asking for? Oh, they're asking for r. Okay, so cool. So r is equal to mv over qb sine theta. I think. So let's see what we got. So mass was 5 times 10 to the minus 12. V was equal to 1 kilometer per second, so 1,000. No one likes mechanics. I tried it once in Twitch. Very hard. Would not recommend.
Oh shit, not good.
Yeah, I do mechanics. I've taught a lot of mechanics. Okay, and then this is going to be 5 times 10 to the minus 6. And then B is 5 times 10 to the minus 3. And this is a cool thing. Sine of theta. So theta is equal to arc sine of 0.9. So you have sine of arc sine of 0.9. These are just going to cancel. What's up? This is Pen. I could tell the elements math. Is this? Oh yeah. You do have a whole thing called the elements, right? That's your whole Discord server. I'm dumb.
Disqualified.
I'm kind of tired. Okay, so let's see what we get. So 5. Yeah. Well, you also took nightmare level mechanics, dude. I wanted to give you a better textbook pen, dude. you were doing like insane level stuff. Like you missed. Yes, exactly like you. Times 1,000. Divided by 5. E to the minus 6. And then divided by 5 e minus 3. And then I think we divided by 0.9. So what do I get? I got 22 centimeters. Fuck, I got 36. Ugh. Damn it. Oh, wait. Find the diameter. Oh. So I would multiply that by 2 technically. But that's still not going to help me. I'm still in a bad place. How do you do number theory advanced questions? If you submit one, I can try to do it. Let me take a look at it. Why the fuck did I not get this right? F equals QVB, right? Yeah, QVB sine theta. We have sine. And that's equal to mv squared over r. We cancel off one of the v's. mv over qb sine theta, right? Yeah. And then that's mass. V is 1,000. Q is 5 times 10 to the minus 6. Yeah. And then b sine theta. Oh, you know why? Oh, wait, no. Arc sine, no, sine of arc sine should just be the number. Yeah, this should work, but it does not, alas. All right, check my chat real quick. Nuroski, what's up? Did you get your results yet?
Yep.
Okay, you want to tell us? Tell us, what'd you get?
So, first off, I posted the problems if you want to look
Ooh,
at them.
let's go take a look. Let's go take a look at these questions. Alright, let's post it in. XIX, dude, what is this cute ass fucking like mushroom and like what? Dude, what? Just like trying to like defeat. Why are there mushrooms here?
Dude, I don't know.
What are these characters, dude? What's going on?
This
Okay.
is
Oh, it's Game of Thrones.
competition.
Oh, it's Game of Thrones, dude. Do you see how they say Tyrion and Littlefinger?
Oh,
Oh, wait, but there aren't
So that's-
fucking.
yeah.
There are no fucking wizards in Game of Thrones.
man,
Right?
I don't know.
What? What the hell? Okay.
I think
Oh.
each edition has like some.
Well, they are talking about goblins here.
inspiration.
Yeah, they're talking about goblins, I guess. Okay.
I think this. I think it's like fantasy inspired.
Okay, it's fantasy inspired, which I guess mushrooms. Yeah, fantasy. Yeah, got it.
Yeah.
Okay.
Fair
So
enough.
these.
E plus is like the hardest category.
So there were 5 questions, and how much time did you have to do this?
Like 3 hours.
Okay, 3 hours.
Three.
Cool.
Yeah, 3 hours and like 30 minutes.
Thanks, Pen. You have a lovely night too. Okay. And then what's the maximum number of points you can get?
So it's 12 points per question, and the
Oh, that's right.
maximum is, like,
They grade you on like how well you did it, right? Yeah. Because even
Yeah.
if you get the right answer, you have to show why it's right. Yeah.
Yeah, exactly. That's the point.
Okay. Did they give you the breakdown for your score on each one?
No, they didn't.
Or they just give you the total?
Yep.
What was your total? So it's
Like,
out of 60.
Yeah, they gave me the total like on each problem, but they didn't explain why.
Oh, that's okay.
That
Give
was
us
the point.
let's build some suspense, dude. What was the total on question 1? What'd you get out of 12?
Well, the first one was easy. I got 12.
12 out of 12. Nice. What about the second one?
Yeah. The second one, so the competition was a team effort, right? It was me and 2 other people.
Oh, okay.
I did the first problem, the third one, and the fourth one, and my friends worked on the second and the fifth one, right?
Okay.
So I'm very proud to say that my team was formed out of me, another guy, and a girl, and she
Okay.
managed to do the second problem by herself. And
Nice. She got 12 out of 12?
Yeah.
Nice. Okay, 12 out of 12. Good job, girl. Okay.
Exactly. Yeah. The third one, well, I did it, so it's 12 out of 12.
He's like, well, I did it. It's 12 out of 12. Okay.
I worked a lot on this one. Like, it took me a lot to figure out.
What about the fourth one?
The fourth one, I got it wrong.
That's dope.
What'd you get?
I got to the right answer, but I didn't explain like why, and I didn't know how to explain why. So I got
Okay.
like 8 points.
8 out of 12. That's still decent. Thanks,
Yeah, that's
Trollcats.
still good because I kind of guessed, right?
Yeah.
So that's not loud. And the fifth one, like we had no idea. Okay.
Is this like the hardest one? This is like the absolute hardest one. Is the
Yeah.
last one? Yeah.
Yeah, after the competition, like when we were allowed to like search on the internet and stuff, we figured out that the fifth one was taken from an international competition.
This
Like
is
in
this
the
is your
international
favorite, dude. It's
platform.
inequalities, bro. It's your favorite.
Well, no, it's it's sequences. It's bounded sequences, and it's very difficult. It was apparently taken from the 1990 International Math Olympiad, like the final problem or something. It's very like
Well, what'd you get on in this though? Then, if it was insane.
I didn't do anything. Like
0 out of
we got
12?
it completely wrong. Yeah, we got it completely wrong.
Okay, so this
Like,
one was tricky.
it says like, does there exist an infinite bounded sequence? And we just said no.
Does it
But
turn out there is?
actually,
Apparently
yeah,
there is. Oh.
You have to like guess it, and it's very hard to guess.
Oh wow, that's crazy. Cause like depending which one you're trying to prove will be like a different way of like trying to.
and
Yeah, I see.
If you just say like there isn't any, and you prove there isn't any, like you're.
I see, because
tricking
you're
yourself.
either like trying to show there is a case or like there isn't and it's a contradiction or something, right?
Yeah. Like we
Okay.
kind of tried to prove there isn't, but we apparently didn't.
So what? So in total, your total score then was a 44 out of 60, right?
Yeah.
Nice.
My man.
What does that place you at?
Apparently, yeah. I 6th or what
Sixth place. Nice.
Yeah.
Out of how
So,
many?
yeah,
How many
I don't-
people?
Let me check, because I forgot. So how many? 1, 2, 3, 4. So there's 10 people per page. 1, 2, 3, 4 pages, 5 pages. So it's out of 50 people. Like
Sixth place out of
15, sorry.
50. Wow, dude, that's nice, dude.
Yeah.
Yeah, dude. Yeah, that's sick.
Nice.
Very good job, Narowski. We can do some of these at some point. I think maybe it'd be fun for you to explain. You said like this one was a huge bitch, right? This one, or
Yeah,
no, number 3.
Number 3, like I did it, but it's like the solution is 8 pages long.
Oh, never mind.
Huh?
Maybe we won't do it.
No, it took me like 2 hours to solve.
Oh my god. Okay, we're okay then.
It's
I
just like for fun, if anyone wants to try it.
Got you. Nice. Okay, that's cool. Where did I screw this one up, by the way? Wait, what? Wait, 1,000. Very cool, Narosky. That's cool, though. I want to know why I didn't get this right. R equal... Dude, what did I do wrong here, dude? What? Excuse me? QVB.
I think you're not supposed... I think you're not supposed to include a sign there.
You think I'm not supposed to? But isn't it? It's V perp. It's the perpendicular component of V to B. So doesn't that have to be V sine theta? If the angle between the magnetic field and the velocity is arc sine of 0.9. I feel like it has to be. Yeah. Oh, you know why? Oh. Wait a minute. Yes. I see. Yeah. It's because this is also perpendicular to the angle. Oh, I see. So this is V sine theta and then squared. Okay, I get it. Okay. So then one of these cancels, but then you get sine squared theta over sine theta. So one of these cancels. Okay, so then it's MV sine theta over QB. Got it. That's what it is. I forgot that, yeah, when you do V squared over R, this is also V perp. Got you. Okay. So then I think I do get the right answer. Right. 5, 1,000, but times 0.9, 900 over 5. 5. Great. Yep. Okay, cool. Yep. That's what it was. Equals, so that's R, so diameter equals 0.36 meters. Wow. And then, yeah, if you want the pitch, that's like the amount. So you have to find the amount of time it takes for it to do one revolution. And then...
Oh, so that's just 2 pi r over v perp, no?
Yes. Yeah, it's 2 pi r over v perp. Yes. Should be. And then the pitch is, right, v parallel times that. Yeah, which is 55. Okay. Yeah, right? Shouldn't it be? Yeah, 2 pi r over v perp. We'll see if that actually works. Sorry, wait. Period would be equal to 2 pi r over v perp, which v perp we already figured out is 900. And then r was 0.36. No, r was 0.18 over 900. That's actually a very, very small time. Yeah, they got 10 to the minus 3. I guess that kind of works out. Let's see. What's up, Nigel? What are you interested in? Hi, I am interested. I am tired. 900. Yeah, 1.25. Yep, that's what they got. Cool. What textbook are these from? That's a good question, actually. I don't know. 10 to the minus 3 seconds. And then you do, yes, V parallel times this. And so V parallel, this is equal to V cosine of arc sine of 0.9. So let's see where our calculator is. So if I do... And then this, yeah, make sure this is in radian mode. I guess it doesn't matter.
Well, cosine of arc sine is an identity, so you can just plug it in.
Yeah.
It's like a square root of 1 minus...
It's 1 minus the square root of 0.9 squared, yeah. You're right.
Yeah.
Yeah, because it's just building the triangle. I just don't want to type that in. 435! So you do 435 times... so this is 435 meters per second. And then you multiply that by that. Okay. Times 1.25. 0.25. E to the minus 3. And you get 0.54, which equals 54 centimeters. Nice. Cool. This is SL Aurora, the book. That's what it's called? Okay. Pitch. Yeah. 55 centimeters. Okay, cool. Who was it? I think this was Pie's question. Pie, was this your question? Yes. Lucky Cat, you're up next.
In America, are there like textbooks like that everyone uses, or no?
Yeah. There's just there are like general like physics books that most people use, like I like the one by like John Coley. John Coley gets used a lot for like undergrad level physics. Graduate can be anything from Jackson, who's terrible. Or
What's up, Short King Pirates? Thanks for the follow. Short King Pirates, that's a fun name. Oh man. Griffiths. Griffiths is a big physics textbook person. Yeah.
But in high school, there aren't any.
No, high school is just all over the place. Yeah.
Yeah, that's the difference, right? So like in Romania, we have like textbooks, but it's like we have textbooks from 2007, which isn't.
well, I mean, physics hasn't really changed since 2007 for at the undergraduate level. I mean, I guess the education has a little bit. Okay. Lucky Cat, what's the question here, though? Please review the following list to ensure the characteristics of drawing the cells, figuring out the anode, cathode, showing the flow of electrons, and identifying which one will be dissolving, which one will be getting plated with fresh metal. Oh. I think the one that oxidizes is the one that... Is that the one that like, I've never heard of fresh metal. Yeah. It's the... Okay. It's the one... It's the electrode that is taking whatever the ion is out of the solution, and it's like it's placing it on the electrode. I believe I think the one that dissolves is oxidizing. So in voltaic cells, which electrode dissolves and which one gets plated with fresh metal? Yeah, okay. Yeah, so the anode is the one that dissolves as it oxidizes. Yes, so the one that oxidizes, I was right. Oxidizing is the one that loses metal. And then the cathode, which reduces, that's the one that gains fresh metal. Because it gains electrons. Exactly. Yeah, Lucky Cat has it. Lucky Cat knows what's up. Yeah. Yeah. Wait, what's this beaker? Oh, these are two separate these are two separate voltaic cells. Yeah. So these are... Yeah. We did this before, right? Where is this? I need like a blank diagram of this. Let's see. Voltaic cell blank diagram. There we go. That's what I want. Okay, I think I like this one. This one's got like a better diagram. All right, we'll do voltaic cell number 2. Okay. So the key thing is to figure out what the standard reduction potentials are. This is what I need. This massive table Or actually, no, this one's actually better. Let's take this one. I think we used this one before. Because you want to find out which one is like more positive. Because, okay, so, yeah, let's pretend we're not... I think I did this one for you already. Let's do voltaic cell number 2. Here, let me... yeah. Okay. All right, so yeah, let's do this one then. We haven't done this one, Lucky Cat. Let's do this one, the FeCu. Okay, so Fe is way down here. Where's Cu? Copper's pretty high up, I thought. Yeah, there you go. Okay. Okay, so copper has a higher potential, which means it's the cathode. So this is cathode. And then this is anode. And then the thing you learn, right, is anox cat red. So this is the reduced. This is the oxidized. So that tells you that also this one will be dissolving. And then this one will be getting plated. Right. Oh. Okay. And then, what else do they want? They just want the flow of the electrons, I guess, yeah? So electrons always flow from anode to cathode. So electrons flow. So you'd say from beaker 1 to beaker 2. Okay. We know the flow of electrons. We know this. We know this. Ooh, figuring out the reactions. Yeah, we can do that. That's okay. So, let's see. Reduction is gain of electrons. So that's going to be this one. So that's going to be Cu2 plus 2 electron minuses is going to get you to Cu solid, yeah? And actually you can see that here, right? Because if this is CuNO3 2, that means this must be 2 plus, right? Because NO3 is a 1 minus. Okay, so this is the cathode reaction. The anode reaction is Fe. Fe is also going to be a 2 plus. Okay. So that's going to be Fe. Sorry, that's going to be Fe solid is going to go to Fe 2 plus 2 electrons. Oh, it's nice. These actually balance, which is great. Okay. And then they want the drawing. Right, we can draw. That's fine.
Nice.
So this would be, you're going to have like Fe NO3 2. This is going to have Cu NO3 2. And then what is this? Fe solid, Cu solid. And so the electrons are going to flow this way. And then if you want to find the potential, let me think how I think you do this. I think you do this one minus this one. So I think delta V is going to equal 0.34 minus 0.45. So that should be equal to 0.79 volts. Which I think you want to show. You can make 0.79 volts. And I think that's it. Yeah. So the main thing whenever you're starting these questions is just look at the standard reduction potentials, figure out which one's higher, and then everything else just kind of follows, right? Anox, cat red, electrons are anode to cathode. The reason you know this is these things are negative, cathode is positive, and electrons are attracted to opposite things. That's why the electrons move towards the cathode. how do you know where is the flow? So electrons always flow from the anode to the cathode because anode is negatively charged and the cathode is positively charged. And so electrons want to go towards the more positive thing. So that's why they move towards the cathode. So that's what happens here. This thing here, right, is the cathode. And then this is the anode. I think so. Pretty sure about that. Mini, what's good again, Julian? Good. Okay, the fresh metal thing. Yeah, okay. So fresh metal is always on the cathode. So this is the fresh metal. Done with your first year exams. Dope, dude. So fresh metal is here. And this one is the one that's dissolving. Oxidation is bad for metal. You should always know that, right? Oxidizing is why, like, rust happens. So whenever you start, like, removing metal from things, think about rust. Rust is oxidizing, and so whatever thing's getting oxidized, which is the anode, that's what loses metal. Yeah, cations and ions go together. They do, right? Cations are positive, anions are negative. You used to call fresh metal the precipitate. I mean, that's true. That is true. You can also see that here, Lucky Cat. Do you see how the cathode reaction produces as its product a solid, whereas the anode reaction takes a solid and produces like aqueous? So this is like taking solid and making liquid. This is taking liquid and making solid. Time to lock in 2 weeks for Calc 2. Yeah, lock in, dude.
Good job.
Does that make sense? Lucky Cat, yeah? Yes? Nice. Okay, cool. Awesome. Feel free. Ask me anything else that doesn't make sense on it, but it's a cool one. Lucky Cat. It makes sense. We love that things make sense. That is dope.
That's dope.
All right. 4 is done. Bryson. What do you got for me, Bryson? Ooh. Is this thermo? We doing thermo? You're gonna hurt me, dude. You're gonna hurt me with the thermo. And then Tavia, I will do one of yours after this. I'll extend the clock more time. You guys got me. You guys got me. I have nothing else after this. It is the last office hours of the year. I'll go longer. Tavia, I'll do yours after this, if that's cool. Because I know you got a physics exam tomorrow. All right, let's see. 10 kilograms is submerged in a water bath, and both the water and the slug are at temperature 10 degrees. An electrical current is passed through the slug, depositing energy into the aluminum. How much water in liters is minimally required just to keep the slug from melting? Ooh. That's kind of cool. This is a fascinating question. Delta HF? Do I need that? I think I only need this. Or maybe I do need delta HF. Kilojoules per mole. Oh, that's heat of fusion. Right? Is that delta HF? I feel like it is. Yeah. Okay. The slug from melting or the water from boiling? Wait, how much energy is being dumped in there, though? Wait, what? This is a what? This is a mindfuck of a question. Wait, what? They're both at 10 degrees. So the water, it's passed through the slug. Dude, yeah, dude, it is so much, it's confusing. The water is gonna boil before the slug melts, right? Oh, pretend the boiling doesn't happen? Fascinating. Oh, I guess it depends how much water is there. Oh, okay. I think I see what we're happening here. Okay. Yeah, it screwed me up so hard. Yeah, seriously, Short King. Like, what? I'm like, fuck. Okay. So, to go from 10 degrees to 660.32 degrees is basically a delta. I'm going to say 650 degrees. I'm going to be lazy. All right. Or actually, whatever. We'll say 650.32. So, Q equals MC delta T. So that's going to be 10,000 kilograms. 10,000 grams. 10 kilograms. Times 0.9 times 650.32. Cool? It's kind of a weird... I mean, that'll tell us how much... Oh, I get it. That's the amount of energy needed to get this thing to melt. And then we're gonna make sure that amount of energy doesn't cause a certain mass of water to boil. I think I get it now. Kind of weird. Ooh, what did I type in wrong? Oh, you can't put commas. Yeah, duh. Wait, what? The fuck? Oh. 10,000. So what is that? That's a big number. Can I just divide that by what is that? That's like 1 million. Okay, 5.8. This is 5 times 10 to the 6, or 5.85 times megajoules. Okay, so that's how much energy. That's how much energy you need to dump into the metal to get it to melt. But I want that to be dissipated by the water, right? I don't do too much OChem, but I have friends that do, and they would love to. I'd love to help out. So if you want to submit a question, I can pass it to one of my friends. I cannot concentrate after 2 hours of studying. Somehow you do. Yeah, I know.
Oh yeah.
It's impressive, I guess. Okay, so this is the heat dumped into slug. That's how much heat would be needed. But I need that heat to cause this thing not to boil. So we're gonna do at the boiling point. So, which would be water. The melting point is not 100 degrees centigrade. What? This is like not fucking right, dude. What? No. This is the boiling point. Boiling. Correct. How do you remember all this stuff? I use it all the time. Yes. Well, wait, they want liters eventually. Yeah, so let's do this. Okay, so 5.85 times 10 to the 6 needs to equal the mass of water times 4.186 times the change in temperature here would be 90 degrees, right? Yeah, okay. Oh, ice melting? Oh, wait, what? No, stop. Stop. Stop, no, it's not that. Okay, divided by 90. Okay, so that's the mass. So 15535 grams, and then that's milliliters, which is the same thing as milliliters. So then just divide by 1,000. Okay, cool. So 15.53 liters. I think that's just it, right? Is that what you got? You have 15.56? I think it's good. Wow, that was a weird question at first. Well, because I was thinking, like, I'm like, wait a minute, all the energy is gonna just keep dumping into the water. But I'm like, the water is gonna boil first, 100%. But I guess it depends how much water there is. Like if there's an ocean, the water won't. But it's like, wait, isn't the energy? I guess it depends on like how quickly the energy dissipates from the slug to the water. Yeah, no, I agree. Yeah, no, I thought the same thing, Short King. Yeah, that's just weird. What about ice melting? Ice melts at 0.
My man.
Okay. That's a cool question, though, Short King. Whose was this? This is Bryson's. Bryson's. Oh, I didn't post. Wait, let me post your answer, Lucky Cat. I don't know why I didn't post it. There you go. Okay, great. This wasn't about a real slug, unfortunately not. No slugs were harmed. Okay, let me go back to the queue. Tavia. All right, here we go. These two. Aluminum bugs. Yes. Bugs of aluminum. Okay. Let me separate this into 2 separate questions. 1 sec. Just 'cause otherwise I my mind just starts going places. Ooh, this is good. All right, 2 charges of 2 times 10 to the minus 6 and minus 1 times 10 to the minus 6 are placed 10 centimeters from each other to determine where a 3rd charge should be placed. Yeah, this is great. I love this question. That was a good one. All right. Okay, this one is 2 times 10 to the 6. Or I'm gonna say microcoulombs. I'm just gonna do this to make life nice. And then this one is gonna be -1 microcoulombs. And then there's a distance of 10, right? And they want to know a 3rd charge should be placed on the line connecting the 2 charges so that it experiences no net force due to these 2 charges. Cool. So it will experience no net force if the electric field there is 0. So let's remember that F is equal to QE, right? Where this is, for instance, this is my 3rd charge, and I don't know what that Q is. But it does not matter, because if the electric field where I place that 3rd charge is 0, then the net force on that 3rd charge will also be 0. So what I need to do is calculate what E total is based on these 2 charges. And I think there's a couple regions this could happen. I think we have to check them. Well, let me think. This is positive. I don't think there's a way... You can't get E equals 0 over here. Yeah, this is not possible. Because this is positive, and then this is negative, but this is so far away that it won't be able to, like, overcome this thing. You might be able to get E equals 0 over here, because this is twice the charge of this. Because, okay, so when you're calculating electric field due to charges, right, you have to consider the magnitude of the charge and also how far away it is. So, it's inversely proportional to the distance, and it's directly proportional to the charge. What that means is, if the charge goes up, the electric field goes up. But if the distance goes up, the electric field goes down. So over here, I'm definitely going to have positive electric field from this, because this is a big boy, and it's also very close to it. This is negative, so this could compete with it, but it's so far away. It's further away. So it has less magnitude, -1 compared to +2, and it's also further away, so there's no way the electric field can be 0 over here. Over here, it might work. because this thing has more magnitude of charge than this, so it has a greater effect than this one, but it's also further away, so we have to kind of determine. Wow, Breasticles, you passed Thermo. Wow, congratulations. Excellent, excellent, Breasticles. I'm very proud of you. Do you never have to deal with Thermo again in your life? You were the one that was asking, right, about the PV NRT diagrams, or the PV diagrams. I think some of these were your questions. Where was it? Was it this shit? What were we doing? No. Yes, this one. Were these your questions? This was like this was a fucking nightmare, dude. These were like not fun. Or I think, actually, that was actually 2 other people. I remember that now. I was tweaking at the end of the semester. I didn't ask about any PV, but it would have been helpful. Okay, all good. Cool. I'm glad you did better. I'm glad you passed. Nice. All right. Tavia, does this make sense so far? We're gonna check. Let's go check what the E field is here. So we need to come up with a coordinate system. I'm gonna call this. So you have to come up with some place where stuff's equal to 0. I'm gonna say x is equal to 0 here. Okay. So if we consider in here, right? So let's say for x is between 0 and 10. Oh, nice. PDEs? Yeah, PDEs is rough sometimes, dude. Wow. I never took PDEs. Ooh, Amit has it. He says it's 10 over root 2 plus root 2. We'll see how it works. Let's see if it works. Okay. Let's consider what the electric field would... So remember that electric field is equal to the sum of KQ over R squared. So in this case, if this thing is located a distance x, then that's going to experience a positive electric field from here. So that's going to be K times 2 microcoulombs. And then R squared there will be x squared. And then it will experience a negative electric field from this one. And so that's going to be minus K 1 microcoulomb. I just took the negative and put it out front here. But then this distance, okay, is here. That distance is 10 minus x. Okay. And I need this to equal 0. So that's one case. That's if x is between 0 and 10. So luckily, a lot of things cancel, right? Microcoulombs, Ks, and Ks. So what are we left with here? We're just going to have 2 over x squared is equal to 1 over 10 minus x squared. And I'm doing everything in centimeters. So what's that? Or 10 minus x squared. My bad. Okay. So 2 times 100 plus x squared minus 20x is equal to x squared. So that's 2x squared minus 40x, and then plus 200, but then we also have minus x squared, so that's just going to become x squared. So x squared minus 40x plus 200 equals 0. I don't know if this is factorable. I don't think it is. You're only a sophomore. Wow, that's impressive, dude. Taking PDEs? That's crazy. Okay, so at this point, I just need to solve. X equals negative b plus or minus a square root of b squared. So that's going to be 40 squared minus 800 all over 2. So that's 40 plus or minus the square root of 1600 minus 800 is 800 over 2. This will come out as Square root of 800, what's that? Oh, 10 root 8. Oh, 20 root 2. That's actually really cool. Yeah. Yeah, so square root of 800. That's 100 times 8, right? And then this is already like 10 times 10. And then this will be 2 times 4, then that's 2 and 2. So you get 2 times 10. So that's 20, and then you're left with a root 2 in between. So you have 40 plus or minus 20 root 2 over 2, which, yeah, is 20 plus or minus 10 root 2. I think that's what you got, Amir. Yeah, right? 10 root 2 plus... Now, here's the cool thing. The answer can't be this one. It can't be the plus one. The reason why is 20 plus 10 root 2 puts me over here. Right? Because that's greater than 10. But once we're out here, the signs on these things will flip. Right? Also, this distance won't work. Like, this is only defined for x is between 0 and 10. We have to use a different equation when we start looking out here. This will end up becoming x for both of them instead of doing 10 minus x. So we have to use only the minus one. So it's 20 minus 10 root 2. You can't use the positive one. And then, so what's that? 20 minus 10 square root of 2. And so that's 5.86 centimeters to the right. Yeah, so positive is too much. Okay, then let's look for it being further away, right? So let's say 4x is greater than 10. Well, now this equation is going to change. Because now this is over here. Okay. Let's move this down. So now the electric field, due to this one, is this direction. It's still minus. The other one's still positive, but then we have to, like, kind of change what's happening here. So now when you're calculating electric field, yes, this is still x squared for the electric field due to the red one. But this will not be 10 minus x. This will now be x minus 10. The reason for that is, right, this is always the distance from the charge, right? And so this distance right here is now x minus 10, right? Because it's the full x minus the 10. Here, this distance was 10 minus x. So they flip. Ooh, very cool. But same thing. You're just going to get a bunch of stuff canceling. Microcoulombs cancel with microcoulombs. And so you're left with 2 over x squared. Or here, let me just see if I can just adjust this. It's going to look like basically the same. Except it's x minus 10. Oh wait, but that's the same. Yes, electric field is not scalar. Electric field's a vector. Potential is a scalar. Oh, wait, but x minus 10 squared and 10 minus x squared is the same thing. Oh, wow, okay. So that's actually kind of cool. Oh, okay, so then you're going to get the same thing. But in this case, now x needs to be greater than, and so the other one works. Some of my thermal classmates took modern this semester. Average was a 12 out of 50. There, okay. There you go. Minus is too little. So you have to do the plus one now. Because this was only defined for it being, yeah, okay. So what if we do this plus? Oh, actually, oh. Damn it. Wait, Tavia. I screwed this up. Damn it. I screwed all this up. This is my late night brain is not working. Okay. Electric field is positive this way. This way it pulls it in. This way it's also positive. I'm silly. Yeah. Oh, wait a minute. So I don't think there's anywhere in between this works actually. Yeah. So ooh, okay.
No.
Actually, there's just one slight little modification we have to do. Sorry. So here's what I meant, Tavia. So this. No. But Amir, we just have to. The electric field just needs to be equal to 0, though, right? And so here, electric field is to the right from this charge. And then from the other one, it's also to the right. Because electric field points from positive to negative. Sorry, 1 second. I gotta change my music again. Am I? Electric field is electric field is not a scalar. Electric field is a vector. I think you're getting it right, yeah. Yeah, so actually it doesn't work here at all. Can't work. Yeah. And here it can't work either, because this is positive but stronger, and then this is negative but weaker. Yes, it would, yeah, no matter what the thing was. Well, I mean, unless the charge is negative. Okay, so wait a minute. So don't even worry about this. So this is just can't happen. Yes, it would never go between them. Yep. Luckily, the math, we conserve a lot of the math for doing it when it's outside. This is the only possible. It's okay. We basically did the same thing. So you just need the positive one, because minus is too little. And so that's going to be, yeah, 34.14 centimeters to the right. The force can be 0 in the middle only. If we are considering the electric field, then the other point will come to the right side of 1 microcoulomb. Yeah, no. So there's always an electric field here, right? Because you're going from positive to negative. Always an electric field. Here, you have like negative from here, pulling electric field in, but then this is pushing it out. And then this is more charge than this, more magnitude, so that's why it's possible. It's not possible here, because the thing that opposes this, which pulls it in, is too far away, and it's also less magnitude. Okay, I think this is 34.14 centimeters to the right. Okay. It says 24. I don't think it'll be 24. Let's see. Yeah, I'm just curious. I think I did this right. Yes, it has to lie to the right of Q2. I agree with chat. Yep. It says x plus 0.1? Shouldn't it be x minus 0.1? Yeah, they got 24 as well. Okay, let me see. What are we doing? What are we doing? What are we doing? What are we doing? Oh. No, you're right. So it's 24 centimeters to the right of Q2. I was saying 34 centimeters to the right of Q1. It's the same thing. No, it's right, Tavia. Yeah, sorry. So, because I was measuring this as my 0 point, so 34 there is technically 24 from here. Yeah, there we go. Nice, cool. Yeah. Can I do an electrochem problem? I did an electrochem problem, actually, earlier. That was this one. This is electrochemistry, right? Nice, Tavia. Okay, I'll save this for you. I think there was a diagram you needed for this other one, maybe here. But same thing. Just calculate E, like KQ over R squared to wherever it is, and then you need to break it down into components and just like have the components cancel each other or something. Yeah. All right, that was Tavia again. Man, I almost like totally fumbled that one at the beginning. We've almost hit 4 hours. I'm getting tired. Anyways, I hope that helps you, Tavia. Good luck on your physics exam tomorrow. I wish you the best. Make sure come by the Discord, because that's where I post all the answers. So all your answers are like in here. They're like little things. I'm gonna add some stuff over the holidays to also like, because all of the streams get recorded on YouTube and Twitch. I'll have something that also puts the timestamp for where we did it, so you can watch it again. Yeah. Okay. Let's see what we got. Black and yellow never showed up. Narosky, what do you got? Oh, well, this was the this was your question.
Well, I just added that.
Oh.
Yeah.
I don't know if I can do it in 13 minutes because I'm like absolutely dead.
Surprise, motherfucker.
No, you don't have to. You don't have to.
But I think it's cool. You said one. I actually probably would be fun about. This is the last office hours of 2025. It is. Yeah, we are gonna still stream on Monday though. So make sure go join the Discord. We're gonna do a big Santa Gold giveaway on Monday. It's a big celebration for all the awesome stuff you guys have helped us out with and growth and metrics and stuff. And it's been an awesome year for everybody on the stream. The stream as well. I can't speak words. All right, let me see. I think Pi then. All right, Pi. What do you got for me? I don't know if Pi gave me a nice one actually. What the hell is this, dude? What? Pi, what did you do? Naman, if you have a question, submit a screenshot to the website there, actualofficehours.com. That's the best way for me to help you. 11 equal wires of equal resistance form an edge of an incomplete cube. Find the total resistance from one end of the vacant edge of the cube to the other. What are all these X's and Y's going on, dog? What? Wait, whoa. Is this like the length? Sorry, what? Or is this a coordinate system? Pi, what's going on here, dude? What are the numbers? What does X minus Y mean? Certified chef, I just saw my math test results and I got a 50% upon my 97 average. How does this happen? Oh, it's okay, man. Yeah, I know. Yeah, sometimes things don't go the way we wanted them to go. You got a 50% on your final, but you have a 97 in the class. Luckily, the 97 will probably buffer things a lot. But if you want to figure out how much your grade is going to drop, take whatever the percentage is of your final and then cut that in half. And then subtract that from 97. Yeah, does X and Y represent the current here? I don't know. I'm really confused what X and Y are. One of the heaviest exams? Okay. Well, take that, certified chef, and, you know, learn from it. And see how you can do better on the next one. Or, like, what things you didn't understand. That would be my best advice. Also, if you have your exam, you should always, like, just post it so, like, we can go over it on the stream and, like, help you out. Like, see what things didn't make sense. Like, see where the gaps in your knowledge are. What was the test on, Chef? I know you said math, but, like, what type of math? Oh, these are currents. Oh, these are currents. I see what they're saying. Yeah, wait. Okay, because if you have 2x current going into here, and then that means x and x goes this way, but then this is y, and then this is x minus y, x minus y. Oh. Because current into a junction has to equal current out. So x into here has to equal x minus y plus y. Oh, very fascinating. And then, yes, current in here, which is x minus y and x minus y, is 2x minus y. This is cute. This is really fucking cute. I see it. I feel like that's currents and the letters are nodes and Kirchhoffs. Yes, I agree. It was parabolas. Oh, okay. Yeah. You should know parabolas. It's not too bad. Math is so boring and unnecessary. Literally every single subject is 10 times better. Stop, dude. Stop. Dude, you know what the Oxford word of the year is? You know what it is? It's rage bait. You, sir, just committed rage bait.
That's dope.
By saying math is unnecessary and everything is 10 times better than it. Congratulations. Wrong. Yeah, okay. Find the total resistance. Okay. Well, I don't know. What am I supposed to do with X and Y here? Sorry, what? I would want to like draw this as a I want to draw this as like a circuit. I don't know what they're doing. I feel like we've done this before, by the way. It ends up being like a bunch of like parallel and perpendicular things or something. Okay, so let's say, for instance, this represents this. And this is going to come in, and then let's say it's going to break up into two green things. It's like green in here. Okay. I want to become good at calculus. Any advice? Making sure you have a solid foundation in pre-calc, which I know is boring. But honestly, if you want to get good at calculus, it'll help you wonders if you understand pre-calculus. Like, so making sure you're solid on, like, your logarithm rules, trig functions are very important in calc. And then, if you have that down, you're going to have a good time. Because, you'll be well equipped to do things, you know. Otherwise, if you're having to remember trig stuff that you never really mastered, it'll really like hold you back, I would say. I think if you just make the matrix and solve the system and then use Ohm's law to get the resistance. But what am I doing with the matrix though, Breasticles? I'm curious. Thank you, Noble. I appreciate it. I think we just hit 11K actually, by the way. Oh, that's okay, certified. No, I know that. That's called test anxiety. Yeah, where you had everything you thought down, and then you got into the test, and it was like, oh shit. Huh? No. Yeah, that happens. The best way to fight that, I always say this, is to make sure when you're studying and learning things that you're also doing it in the same environment that you would be to like take a test. So you know, if you say like I know things and I learn things, but you did it, you know, while you were in bed, like on your phone watching TV. Unfortunately, when you get to like a testing environment where like you have to be quiet and things are like kind of high pressure and like there's no distractions, your brain doesn't go into the same place that it was when it was learning. And so you kind of like, you screw up.
Bruh.
So, dude, it's natural. It happens all the time. But just little tips. All right. All right, let's make some pink lines maybe. Fucking just drawing things. So this splits out, right? I don't know. I feel like this like may like turn into something. I think you could get the matrix using Kirchhoff's laws. Oh, you mean if I did like KVL stuff? Yeah, probably could. But here's a cool thing. Wait a minute. Okay. I feel like this one connects to this one. Right? So like the one end of this connects to the end of this other one. Because they say all the wires, 11 wires by the way, dude. What? Why are you doing that to me? This connects to this one. Yeah, because that's this node H. All right, but let's keep going. And then once they connect, we need them to keep going this way. So then they keep going. Yeah. But then what's weird, yeah, okay, is that like, so once this splits into this, but this also splits to something else. Oh, man. Because I do need these to connect. Let's see. I'm gonna run out of colors. Shit. Alright, let's do this. Right? And then, okay, here's what's cool. Is that blue is also going to connect to this pink. Right? These connect. Oh, I think we're close. Wait, no. Wait. They haven't connected yet. Sorry. Blue goes, that goes to here. And then this like comes backwards? Oh my god. It does look mad. It's pretty mad. I don't know if I'm gonna get it in the next 2 minutes. I'm gonna try. I think the author just wanted to be cruel. I think they did too. What's up, Justin?
Yep.
I'm getting violated on this question.
Oh, it looks like a fucking heart rate monitor, I'm not gonna lie.
It does, doesn't it? Yeah. Wait, the blue then siphons to meet this one? I don't know. we're basically like, I think the A and B is the vacant edge. At A, the current 2x. Yes. I agree. No, I agree, Amit. I agree, Amit. That's what's happening. I'm just trying to like draw like what that turns into. Right. Okay. And then look. So then this one and this one connect to each other. Got it. We need more colors. We're running out of colors. I needed 11 colors. Let's do this. I'm gonna do this and this. This and this connect with each other. Cool. Got it. I believe it's that time. I think it. Yeah, 2-1. Yeah, we're running out of time. Okay, I think this is it. Yeah, there we go. That's your circuit. What is that though? I mean, it's actually not too bad, right? You see that these two are in parallel, and then this comes all the way back. This is like a wheat stone that's happening, no? Makes sense to me. Okay, cool. Okay, all right. We've been on for almost 4 hours. Let's close out the stream. All right. Thank you, everyone, for coming to Office Hours. I appreciate all the questions. A lot of crazy ones today. And I wanted to at least give enough time for... to go through most of them, or we went through almost all of them. Yeah, I do think the author was just being absolutely cruel for that. But okay, all right. That's the last Office Hours of 2025. Thank you again, everyone, for being here and always helping me out and helping me learn.
Bing bong.
But we're not done forever. We're just done until next year. Yeah, we'll be helping you guys solve questions next year. So I highly recommend that you guys, if you want to stay in touch with what's happening next year, make sure to go join the Discord. And so the way you can do that is to go to this website, actualofficehours.com, click join our Discord, and then once you're there, there's actually some cool stuff going on. We're going to do a big giveaway on Monday. So if you come by on Monday stream, I won't be helping out with homework questions, but I will be... Wait, where did my thing go? Oh, I can't find it. Anyways, whatever. So we'll be doing a big giveaway to celebrate the end of the year and all the awesome things we've done. Yes. Happy holidays, Merry Christmas, all that fun stuff. I am going to go raid another streamer. Let's go see who we got. No, not that one. Where is it? There we go. Awesome. But yes, we'll be back in January. So if you ever want to figure out like when we're going to be doing that, the place for that is going to be looking at the streaming schedule here. I will put on when the next stream is. I think I have it scheduled already. I do. I already have it scheduled for Monday the 5th. What's the answer to the cube? I don't know what the answer to the cube is, but it is going to get put into our Discord. So if you want to keep solving it and whatnot, it'll be there. Just go check it out. Trying to find out where my thing went, but can I do ChatGPT? So our bot will do ChatGPT in 2 days on it. So yes, we'll check it with chat in a bit. All right, let's go raid another streamer. See who's on towards the end of the holidays. Let's see, who do we got? Who are we following? Wow, a lot of fun people. Someone's doing destruction. Oh, that's cool. I don't know what's going on there. Finals. Ultrasaurus seems to do Alejandro. Oh, let's go say hi to Penn. Yeah, we like Penn. Go say hi to Penn for us. He's an awesome friend of ours who also streams math, help, and lots of fun stuff. Okay, cool. All right. enjoy the holidays. Merry Christmas, Happy Hanukkah, all that great stuff. We will see you in the new year with office hours, or come by on Monday. We're going to do a big giveaway. So until then, peace.